everyone, very good morning to all of you. So hi everyone, Pujita, Amrita, Rahul, Shiva. So all of you, a very good morning, and I hope that all of you are doing really well and are ready to give your exam, to give your best tomorrow, right? So students, yes, students already started. Yes. So now in this first video of one second, just a minute. Yes, so in this first part, hello Kirtana, Sanvi, very good morning to all of you, right? And I'm pretty sure that all of you are very energetic and completely ready to start the class. So please sit with a notebook and a pen, because we are going to revise the entire organic chemistry, all the reactions, and we are going to solve a lot of questions as well. Okay, so this one video will help you to revise organic and inorganic completely. So do not worry, let's get started. These sessions we will be doing within 2 to 2.5 hours. Okay, so please be patient, because today you have to devote time, right? Today if you get distracted and all, then tomorrow exam is there, so it will be spoiled. So let's focus with full concentration and let's start the session. Okay. Yes, second year organic, definitely. So students, do not worry about PU1 at all from this point of time. The only thing that you need to revise today is your PU2 topics. Okay, so because that is where you can get 40 plus marks, and if you are able to get 40 plus marks, that is a very good mark in chemistry to get a top 1000 rank. Okay, so please target only PU2 chapters today. No PU1 revise, nothing. Just do PU2 chapters today. Yes, organic and inorganic. Yes, Mehak, organic and inorganic. Okay, so one second, let me just adjust the mic. Okay, fine. Let's get started, students. Organic chemistry, you all know what is the syllabus. These are the chapters that we have, and we have lot of reactions in these chapters. So quickly we will be revising the chapters, and then we will be doing questions also. Okay, some good questions we'll be doing. Pujita, good morning. Yes, everyone. Hello Alkinson, hello Arins. Okay, so first, for every chapter, see, for every chapter what you have to remember, what we have to revise now, the preparation method. Okay, then we have to remember or revise the chemical reactions. Okay, these two things we have to revise for all the chapters. Okay, we will take, so please you can take a screenshot of this quickly, just take the screenshot, and at the end of the session you can go and revise them. Okay, or if you have your short notes, you can prepare or you can revise from that. So first of all, let's see the preparation methods of haloalkanes. Okay, so haloalkanes we can prepare from 3 major sources. What are the 3 major sources? First, we have from alcohols, second by using hydrocarbons, and third from halogen exchange method. Okay, next, from hydrocarbons we have 2 things. One is from haloalkanes, from alkanes, and next one is from alkenes. Okay, so these are the 2 things from where we can prepare our haloalkanes. Next, we have halogen exchange method. There we have Finkelstein reaction and Schwarz reaction. Okay, now is it clear? Let us recall once again, let us revise it once again. Haloalkanes I can prepare from 3 major sources. One is from alcohols, second one is from hydrocarbons, and third one is halogen exchange method. Under hydrocarbons we have 2 things. One is alkanes, another is alkenes. And in halogen exchange method we have again 2 things. One is your Schwarz reaction, another is your Finkelstein reaction. Okay, I hope this much is clear. So 3 major sources, and in hydrocarbons we have 2 sources. In halogen exchange method we have 2 reactions. Okay, I hope this is clear. Yes, I hope this is clear. Okay, next, from alkenes we have addition of HX and addition of X2. So take a screenshot of this one. Please, all of you, take a screenshot of this one. You should be revising using this. Okay, you should be revising using this one. So please take a screenshot from here. Okay, fine. Now let us quickly revise. The first method was what? From alcohols, right? From alcohol. So what are the reagents that we can use to convert alcohols to haloalkanes? We can use HCl, ZnCl2. You can use NaBr, H2SO4. You can use PX3, PCl5. you can use X2 red phosphorus, and then you can use SOCl2. Okay, how many methods we have here? 6 methods. First one, we can use HCl ZnCl2, you can use NaBr H2SO4, you can use PCl3, you can use PCl5, you can use X2 red phosphorus, and lastly we can use SOCl2. And what we have to remember about this SOCl2, this is the most preferred method. Why this is the most preferred method? Because here we get gaseous byproducts, right? So these will evaporate and only Rx will be left behind. Clear? So that is about the methods of preparation of haloalkanes from alcohols. Next one was from hydrocarbons, right? From hydrocarbons we have two things, from alkanes and from alkenes. So first we will see how to prepare haloalkanes from alkanes. So if I take alkanes, here we follow free radical halogenation. Free radical halogenation. In free radical halogenation, what will happen? Cl2H nu, if you take, all the hydrogens will be replaced with chlorine. Okay, and you should remember this follows free radical mechanism. Okay, okay. Next, just a minute. Okay, fine. Now moving forward to from alkenes. If you measure from alkenes, or if you want to prepare using alkenes, we have two methods. Okay, one I can use directly HX, and here you should remember that it always follow Markovnikov's rule. In Markovnikov's rule, what will happen? The negative part will go to the carbon having less number of hydrogen. So if you see propene is there, I am adding HX to that. The negative part, that is X, will be added to the carbon having less number of hydrogen in the double bond. Here I can see one carbon, here I can see two carbons, sorry, one hydrogen, two hydrogen. So the negative part will go to the carbon having less number of hydrogen. So X is added and H is added here. That is using HX. And if you use Br2CCl4 or X2 anything, both the double bonds are replaced with X group. Now what is the speciality of these type of haloalkanes where the adjacent carbons are having X? These are called as vicinal dihalides. These are called as vicinal dihalides. Okay, and what do you mean by geminal dihalides? When the same carbon is having two halogen groups, we call it geminal dihalides. Okay, vicinal dihalides and geminal dihalides. Very good student. Yes. Next, coming to last method, halogen exchange method. In halogen exchange method, we have two name reactions, very important. One is Schwartz reaction and another is Finkelstein reaction. So in Schwartz reaction, we produce fluoroalkanes, right? You produce fluoroalkanes by taking metallic fluorides like AgF, Hg2F2, COF2, SbF3, any one metallic fluorides you can use. And in Finkelstein reaction, we prepare iodoalkanes by using NaI in dry acetone. Okay, you don't have to remember any definition or anything, just remember the reagents. Okay, clear? All of you are clear with this? Okay, next. So this is the preparation of haloalkanes. Now let's see how we can prepare haloarenes. Okay, so for preparation of haloarenes, first is using hydrocarbons, second one is using amines. Okay, first is using hydrocarbons and second one is using amines. How can we do that? Now see, if you take CH3 and just take X2 and Fe in dark. Okay, so what will happen? This one is your electron donating group, or it is ortho para directing. So X will be added at ortho and para position. Okay, so that is by hydrocarbons, normal adding halogens to hydrocarbons. Next we have is from amines, and from amines, if I want to do, first I need to convert to this special compound which is called as benzene diazonium chloride. Right? Now benzene diazonium chloride, you can treat it with copper salt, that will give you chlorobenzene or bromobenzene, and if you treat it with Ki, you will get it iodobenzene. Now what is the name of this reaction? This is called as Sandmeyer reaction. Right? Now you can also prepare this one by using copper powder and HCl or copper powder and HBr. So that will also give you chlorobenzene or bromobenzene. Okay, and this reaction is called as Gattermann reaction. Okay, is it clear? Clear to everyone? Yes, students, please tell me. All of you are getting? Okay, that is superb. I think all of you are getting all of this. Okay, very good. Yeah, let's move forward. Okay, next we will have chemical reactions of haloalkanes and haloarenes. Okay, so in haloalkanes, what all reactions we have? Nucleophilic reactions, and if you remember, in nucleophilic reactions, what we have? SN1 and SN2. Then we have elimination reaction, and we have reactions with metals, that is your Grignard reagent and Woods reaction. Similarly, in haloarenes, we have nucleophilic reactions, okay? Then we have electrophilic reactions and reactions with metals, okay? So, okay, let's move forward. Okay, fine. Next, coming to nucleophilic reactions, different nucleophiles and types. So what is generally a nucleophilic substitution reaction? See, you have Rx and you treat it with Nu. So what I will get? Rnu, okay, plus X minus. Okay, so that is what is the nucleophilic substitution reaction. Now, what are the different types of nucleophiles that you need to remember? Very, very important. What is that? And we have, see, if you add in this, there are two nucleophiles which are very, very important. KCN, AgCN, KNO2, AgNO2. Every year questions have been asked from this particular topic, so please be very careful here. Okay, all of you put a star mark in your book if you are having, or note down this one. KCN will give you CN, RCN. AgCN will give you RNC, okay, isocyanide, and this is cyanide. And if you take KNO2, KNO2 will give you RONO, okay, RONO. And if you take AgNO2, you will get RNO2. Okay, are you getting the difference? KNO2 will give you RONO and AgNO2 will give you RNO2. Okay, I hope this is clear. I hope this is clear. All of you, please students, this is very, very important. Note down. Okay, I want all of you to sit with a notebook and a pen and study the class, and please note down these things. These are 4 reagents that everybody should remember. Okay, very important. Let's revise once again. Okay, KCN will give me RCN, AgCN will give me RNC, KNO2 will give me what? RONO, AgNO2 will give me RNO2. Clear? I hope this is clear to all of you. Okay, let's move forward here. Now comes the types of nucleophilic substitution reaction, SN1 and SN2. All of you should be knowing about this, and you don't have to learn these many points. The only thing that you have to remember is the order of SN1 and the order of SN2. What is the order? See, in SN1 what will happen? 3 degree, then 2 degree, and then 1 degree. How you will get the questions? You will be given with 2-3 compounds, and you will be asked arrange them in the order of their SN2 reaction, arrange them in the order of their SN1 reaction. Like this you will get to order them. So you just need to know about this particular concept from this topic. So what I need to know? Ma'am, SN1 is equal to 3 degree greater than 2 degree greater than 1 degree. And what is SN2? SN2 order is 1 degree greater than 2 degree greater than 3 degree. Clear? That much can we remember? Can we remember this much? Yes. Okay. Now let's move. UI Daniel, sorry, Kushal Ravi, this is live beta, it is not recorded. It is live class going on now. Okay, you can put your doubts here. Okay, just a minute. Okay. Okay, next, moving forward. So I might be ignoring your comments here, but let us first focus on continuing the syllabus. We should not be getting distracted at this point of time. In the middle, I'll be taking your questions. Okay, so please don't worry. Let's do the class. Okay. Yes, Kushal, that's what I told you, because I don't want you to people get distracted while teaching. Okay, let's focus on the syllabus. Okay. Yes, shayad calculator is not allowed. Okay, calculator is not allowed. Okay, Next, coming to elimination reaction. In elimination reaction, what you will happen? You have to remove the beta hydrogen, okay, the beta hydrogen and the X group. Okay, and what is the reagent used in this elimination reaction? Alcoholic KOH. Okay, that is the first important thing that you need to remember. Alcoholic KOH is used to remove HX and to get alkene. Now, what is the major product formed here? We have to remember that the major product formed here is Saytzeff rule. Saytzeff product. Saytzeff product. Now, what is Saytzeff product? You can see one example here. I have taken 2-bromopentane. Okay, 2-bromopentane I have taken, and I am using this alcoholic KOH on both the sides. Now, you can see here that this is your alpha carbon, right? This is beta carbon. This is also beta carbon. Beta carbon means what? Carbon next to the functional group. This carbon is containing the functional group, so this is alpha, this is beta. Now you have an H here also, so you can remove this HBr and you can remove this HBr. Both the possibilities are there. So I will get, if I remove this HBr, I will get this alkene, and if I remove this HBr, I will get this alkene, right, which is 19% and this one is 81%. Now this rule says that always the alkene which is more surrounded, okay, or more substituted, that is the major product. How will you find which is the major product? See, you have to see beside this C double bond C, what groups are attached, okay, how many carbons are attached. If more number of carbons are attached, then it is more substituted, and that will be the major product. Now if I see this example, you can see C double bond C is there. To that, what is attached? This side C is attached, this side H is attached, here also CH3, and here also H, right? So that means what? We have 2 carbons here. Okay, beside this double bond, I have 2 carbon groups. Now if I check this side, what I will write? Just I will write this double bond. Okay, you can see this side 2 hydrogens, and this side 1 hydrogen, this 1 hydrogen, and then this is 1 carbon. So besides this double bond, I have only 1 carbon. So which is more substituted? Where there are more number of carbons, that is more substituted. So this will be the major product. Okay, yes, clear? Okay, next, moving to the reactions with metals. So we have here organometallic compounds. In organometallic compounds, what will happen? Rx plus Mg will give you RMgX, okay, and that is called as your Grignard reagent. And next we have Woods reaction. In that, Rx plus Na gives you RR plus NaX, okay. So these 2 reactions you should remember. And what is the speciality about this reaction? The number of carbons is getting doubled, okay. Okay, next, coming to the reactions, that is nucleophilic substitution reaction. Okay, so in nucleophilic substitution reaction, sorry, this is for haloarenes, not haloalkanes, haloarenes. Okay, so now what we have seen for haloalkanes, what are the reactions that we saw? First reaction that I saw was, can you tell me what was the first reaction that we discussed under haloalkanes? Substitution reaction, right? Under that, what you have to remember? KCN, AgCN, right? Then KNO2 and AgNO2, right? Then we discussed about elimination reaction, right? Under elimination reaction, what I have to remember? Under elimination reaction, I have to remember the reagent used, that is alcoholic KOH, and the major product will be Saytzeff product. Okay. Next, we discussed reaction with metal. Under that, we have Grignard reagent, okay, and we have Woods reaction. Right? I hope this much is clear to everyone. Yes, please tell me if this much is clear to everyone. If this one is clear to everyone. Okay. So students, what all things you need to take to the exam, what is allowed, what is not allowed, I'll make a detailed video on that. So please, that video will be recorded today and will be given to you. You can see it in our YouTube channel. So please don't worry about that. Now please focus on the class. Okay. Yes, this is clear, all of you? Okay, fine. Now let's move forward to the haloarenes reaction. Okay, haloarenes reaction. In haloarenes, nucleophilic reactions are not happening. Okay, not easy to happen. Okay, why? Because you can see that in nucleophilic reactions, what happens? If I have a X group and I have a nucleophile group, this nucleophile group should come here and X group should leave, right? So you will get a reaction like this. This should be the reaction. But in case of haloarenes, what happens? This bond is very strong. Okay, this bond is very strong because of partial double bond character or because of resonance. Okay, this bond is very strong. Now because of that, this bond does not break, so we do not find nucleophilic substitution reactions easily. Okay, nucleophilic substitution reaction can take place at very high temperature and pressure. Okay, so now coming to electrophilic substitution reaction. So what all electrophilic substitution reactions are there, you can see on the screen. Okay, next we have, first one is your halogenation. Okay, in halogenation, what we have to do, you have to add Cl2 and FeCl3, where you have to take Cl and there you have to take Cl, means Cl gets added at ortho and para position. Next, for nitration, you can use concentrated HNO3 and H2SO4 and you will get at ortho and para position the nitro groups. Similarly, at concentrated H2SO4 at ortho and para position, you will get SO3H group. Friedel-Crafts alkylation, CH3COCl, ACl, AlCl3 you will get at ortho para position. Simply Friedel-Crafts alkylation will give you this products. Okay. Yes, so please take a screenshot of this one. Aspia, you can take a screenshot definitely. Yes, all of you please take a screenshot now. Okay, so here are some questions. Okay, exam pad is not allowed here. No exam pad will be allowed. Who is asking? Kedar, exam pad will not be allowed. Okay, so I hope all of you have taken the screenshot. Now let's move forward. Okay, so yes, now we will solve questions. Okay, so 10 questions are there. Let's solve it quickly. Okay, so first question, can you answer, all of you? I'm just putting it, question number 1. Okay, Punya, can you please put your chat once again? I can reply. Class duration, Madhumita, we will try to finish the class within 2 hours, but let's see. Okay, 2 to 2.5 hours. Okay. Okay, now please answer, students. No more chat now. Please don't ask any other questions. You can ask at the end of the session. Now please focus on the syllabus or on completing the syllabus. Okay, no other gossips at this point of time. Okay, just answer the question. I want all of you to put comments regarding the answers. I am not going to take any other question now. Only question what we are discussing. Okay, at the end of the session you can ask all your these doubts. I will take it. Okay, now please focus on the class. Yes, students have started answering B. Okay, now see here, Br is there, SN2 reaction. So what will happen? OH minus will attack. But if you remember, in SN2 reaction, what happens? There is an inversion. Means which side Br is there, opposite side OH will come, not on the same side. Okay, so Br was on this side, so OH will not come on this side. OH will come rather on the opposite side. So that is why option number B here. Okay, next. Yes. You have to arrange them. You have to tell me which is the correct statement here. Which is the correct statement? Yes, Venkatesh, this is enough. Please study this much. That will be enough. Okay. What is the correct statement? Which is or are the correct statement? You have been given 1, 2 and 3. Okay, reactivity of SN1 reaction order is given, reactivity of SN2 order is given, again reactivity for SN1 and SN2, different orders are given. So let us first find out SN1 and SN2 order. Okay, so SN1, you remember, this is a tertiary group, this is secondary group and this is primary group, right? So SN1 will be 3, 2 and 1 and SN2 will be 1, 2 and 3. Okay, so I can have the order SN1 reaction first option if I see, SN1 reaction is 1, 2 and 3. Is it correct? No, right? So that is wrong. Reactivity of SN2 is 1, 2, 3. Yes, that is correct. All of you are giving B. Then reaction of SN1 is 1, 2 and 3. Yes, this is also correct. And then reaction of SN2 is, this is wrong. Okay, now here I have given you two statement corrects. Why? Because in option it will be like A and B is correct, B and C is correct, both of this, none of this, like that options will be there. So that is why B and C, if that option will be there where B and C both are correct, that will be the correct answer. Okay, yes. Next question. Which of the following is the correct order of decreasing reactivity towards a nucleophilic substitution? Okay, so decreasing reactivity of a nucleophilic substitution reaction. Now, so you have vinyl chloride, allyl chloride and propyl chloride. So what is vinyl chloride? See, vinyl chloride means where you have chlorine directly attached to the double bond. This is called as vinyl chloride. Okay, next allyl chloride is chlorine attached to the carbon next to the double bond. That is your allyl chloride. Okay, vinyl chloride, allyl chloride. And propyl chloride is normal chloride. Okay, so in which case the SN1 or in which case the nucleophilic substitution will be highest. So now see, whenever you want to do the nucleophilic order, first remove the chlorine group and form a carbocation. Okay, so if I remove this chlorine, I'll get a carbocation here. Remove this chlorine, I'll get a carbocation here. Remove this chlorine, I will get a carbocation here. Okay, now always remember that benzyl and allyl, okay, carbocations are very stable. Okay, so here I can see this allyl carbocation is very stable because of resonance. Okay, so allyl carbocation is very stable, so that will have the highest reactivity. So I have which option with allyl? I can eliminate these two options. Next, vinyl, where the carbocation is present, this one will be the least stable. Okay, and this one is the highest stable. By now see, the carbocation, this is sp2 hybridized carbon, and sp2 hybridized carbons are electronegative, and positive charge on electronegative atom is highly unstable. So that is why this one, after allylic what we will have? Vinyl. After allylic we will have propyl, and vinyl should be at the end. So that is why option number D. Yes, those are saying D, that is absolutely correct. Next question. Again, which one of the following chlorohydrocarbon readily undergoes solvolysis? Now, solvolysis, what we have to remember, in solvolysis, we have to check the stability of carbocation. Okay, stability of carbocation you have to check in solvolysis. Where there is more carbocation stable, that it will be more or highest order of solvolysis. And what is the order of stability? First we have benzyl carbocation, then we have allyl carbocation, then we have 3 degree, 2 degree, 1 degree. Okay, so can we see here for this question? Yes, here if I see you have to remove this Cl, I'll get a plus charge here. You remove this one, I'll get a plus charge here. You remove this one, I'll get a plus charge here, and I'll get a plus charge here, right? So I told you benzyl is the most stable carbocation. And what is benzyl carbocation? Carbocation attached to an benzene ring. So that is why option number A here. Okay, that is why option number A here. Next question, can we solve this question? Yes. Yes. Okay, please solve the next question. Let me just adjust the mic. Okay, please say the next question answer. You have to tell the A, B and C in the following reaction. So KCN, first of all I just tell you it is very important reagent KCN. KCN will give me CH3, CH2, CN, right? So I can eliminate option number D because here NC is formed. Now when you do lithium aluminium hydride, okay, what it will do? It will reduce this group, okay? It will reduce this group to CH3, CH2, CH2, NH2, okay? Amines are formed after reduction. Now if you treat it with nitrous acid, what will happen? This one will get converted to alcohols, okay? Nitrous acid. So remember, aliphatic amines with HNO2 will give you nitrous acid or alcohols, okay? sorry, I told you the aliphatic amines with nitrous acid will give you alcohols. So I have here which option? First of all, I will have CH3CN, CH3CH2, NH2, and then I will have, so here options are not correct, okay. I think here one more carbon should come, okay, and here also you should have one more carbon. So that is why I have option, no, none of the options are correct. Here I also one more carbon will come, okay. So option C will be the correct. Here some printing error is there, but option number C, okay. Okay, next coming to this one, can we guess the answer quickly? Yes. Next students, can we have the question next one? Yes, quickly. CH2CH2Cl, okay, C2H2Cl is there, X. Fluorides we are getting. I just now discussed in which case we will get fluorides. We need to have metallic fluorides, right? So I can eliminate this option. I will have metallic fluorides here. Next, if I want to have double bond, that is elimination. For elimination, I told you we have to use alcoholic KOH, not aqueous KOH. So remove this one, alcoholic KOH we got. Next you see what happens, the number of carbon here is increasing, right? Number of carbon is increasing. If number of carbon will increase, then it is means exactly becoming double. That is Woods reaction, and for Woods reaction what is the reagent? Na dry ether, right? So here it is benzene, so this is also not there. Na dry ether, that is option number C. Very good students, all of you are doing really well and I am very happy to see your performance. Now like this only you will do tomorrow's exam also, and all of you will crack it with very good marks. Let's do the next question. RxNAi dry acetone, right? We know this is the name reaction, Ri, that is which reaction? It is your Finkelstein reaction. Next, with metallic fluorides we will get fluorine, that is your Schwartz reaction. Next, RCOAg-Br2-CCl4 is there, and you have Cu2Cl2, that is your Sandmeyer reaction. So D is your Sandmeyer reaction, that is one, and the first one is your, or third one is your Hunts-Dicker reaction, okay. So which option I will get? A3. A3, I have two options, so I will remove these two. B, what is B here? B is 2, so that is option number A. Yes, mind-blowing students, a very good participation and very good answer. Next, the group is present at ortho and para promotes nucleophilic substitution of chlorobenzene, okay. So now see, chlorobenzene is there, okay. There is some group present at ortho and para, and you want to do nucleophilic substitution, okay. So that group which can promote nucleophilic substitution under chlorobenzene or inside chlorobenzene, which group it should be? So remember, we have done this. This group should be electron withdrawing groups, and it has to be NO2 group, which is a very strong electron withdrawing group, okay. So that is why we will have here option number B. Okay, next, the increasing order of reactivity of CX bonds towards the nucleophile in the given compound. Again, reactivity of CX bond, okay. So where, how will the CX bond will react? CX will leave and carbocation will form. So where the stability of carbocation is maximum, there the reaction will be maximum. Can we see? Remove X from all the options, remove X from all the options and get the carbocation. Where the carbocation will be more stable, there it will be more highly reactive, okay. So can we have here, we will get tertiary carbocation, here I will get secondary carbocation. So definitely 3 has to be more reactive, only one option with 3, so option number B here, okay. And after this, if you compare 2 and 1, here if NO2 groups are present, nucleophilic substitution will take place. So with this, after 3, 4, then I will have 2, and lastly I will have 1 here, okay. Hi Vinay, hello. Next question. This is the last question for haloalkanes chapter. Next we will move to alcohols chapter. Cl2FeCl3. What will this do? Cl2FeCl2. What will this add? A. A will be, see, if you add Cl2FeCl3, you will get Cl. Then HNO3 and H2SO4. Now see, chlorine is an ortho-para directing. Okay, chlorine is ortho-para directing. So NO2 will be attached at the para position. Para product is the major product. Okay, next if I see this one, HNO3 and H2SO4. So first nitration will take place. So here C will be nitration group added, and after that Cl2FeCl3. Now nitro group is a meta directing group. right? So NO2 group will be added to Cl2 or FeCl3 at the meta position. So that is here, right? Clear? Yes. All of you are getting? So you can see here what was the first option. You have to find B and D. See how tricky the question is. You have to only focus on B and D. So what is B? Para nitro, and D is meta nitro, right? So para and meta, right? We will get this one. Here you can see the first one that we got. First one we got is para. So that is why this option, not this option. Okay. So option number A here. Clear? Okay. Next, moving to alcohols, phenols and ethers. So quickly let us see how we can prepare alcohols. Okay. So for preparing alcohols, you can first use alkenes. So basically we can prepare it from alkenes, from carbonyl compounds and from Grignard reagent. Okay, alkenes, carbonyl compounds and Grignard reagent. Now from alkenes, how we can prepare? Addition of water using acid, that will give you alcohols, and hydroboration oxidation. Okay, so here acid catalyzed one will give you Markovnikov addition, and hydroboration will give you anti-Markovnikov addition. Okay. Next, from carbonyl compounds, if you reduce the carbonyl compounds, reductions of aldehydes and ketones and reductions of acids and esters, right? You remember LiAlH4, NaBH4, if I reduce these compounds, I will get alcohols. Next, we will see how we can get from Grignard reagent. Okay. Let's start from there. So please take a screenshot of this one quickly. I am aside. Take a screenshot of this one quickly. And okay, next, after that we will be taking the preparation method in detail. Okay, okay, fine. I hope it is done. So first was what? First method was what? From alkenes, right? So from alkenes you can use H plus and H2O, that will give you Markovnikov addition. Okay, Markovnikov addition, and if I took H2O2 and OH minus, that will give me anti-Markovnikov rule. Okay, so let me give you an example here. If I have propene, okay, propene, and I am taking here that is water in acidic medium, H plus H2O in acidic medium, and I am taking here B2H6 H2O2 OH minus. Okay, so this is your hydroboration oxidation reaction, and this is acid catalyzed addition of water. Here what will happen? The product will be Markovnikov's rule. Okay, OH in water, what is the negative part? OH minus, right? OH minus will go to the carbon having less number of hydrogen. Here we will get anti-Markovnikov's product, that is OH. Okay, so understood the difference? You will get propane 1OL, propane 2OL here. Clear? Okay. Okay. Oh, just a minute, students. Just a minute. Okay, just a minute. Okay, so sorry for the disturbance. Okay, there was a small error. Okay, next, so that is the first rule, that is addition from alkenes. Second one, what we thought? From carbonyl compounds, right? So from aldehydes and ketones, one second, just a minute, students. Okay, so second one was from aldehydes and ketones. So you can use H2 palladium or NaBH4 to reduce aldehydes and ketones to alcohols. And the third one is from acids and esters. So you can use here also LiLH4 or H2 palladium to reduce them to alcohols. And for Grignard reagent, you can take any Grignard reagent and treat them with aldehydes or ketones, you will get alcohols. Okay, let's revise once again. From alkenes, you can use H plus and H2O, or you can use B2H6 H2O2 OH minus. The first one will give you Markovnikov's addition, second one will give you anti-Markovnikov addition. The second method, from carbonyl compounds, you can reduce aldehydes and ketones using NaBH4 or H2 palladium, you will get alcohols. Third method, you can reduce acids and esters using LiLH4 and hydrogen palladium. Okay. Next, we can use Grignard reagent with carbonyl compounds to give you alcohols. Okay, Grignard reagent with carbonyl compounds will give you alcohols. Okay, okay. Okay, let me take some of your questions. Yashu, ma'am, I am solving but not getting more than 25. So Yashu, please, you can just do question solving. Okay, just see the examples and solve, and whichever questions you are getting wrong, revise that again, and next you solve, then you will improve. Okay, if you're just solving without revising, then it will not improve. Okay, yes, Sahana, please tell me whatever you want to say. Yes. Okay. Yes, JJ, hi miss, can I ask you something? If I don't know anything and if I just watch your 2 revision videos, can I score really good? Yes dear, if you watch these 2 videos, you will definitely be able to score good, and you revise all the concepts that we have discussed, you will be able to score good in this one. Okay. Okay, next let's move students, let's move. We have many things to cover. Okay, so next we will see how to prepare phenols. Okay, so methods of preparation of phenols. First one is your haloarenes. Next we have from benzene sulfonic acid, from diazonium salts, and from cumene. Okay, this is very important method from where we get questions every year. Okay, so mark that one. So from haloarenes, how we can get? So you can see the first method from haloarenes. You can take any haloalkane, treat it with NaOH at a high pressure and temperature. This Cl minus will be replaced with OH and we will get phenols. That is the first one. Okay, from haloarenes. The second one was from your benzene sulfonic acid, okay, or from oleum. So if I take benzene and just treat it with oleum, I'll get benzene sulfonic acid. Then with NaOH and H plus, I will get phenol. Okay, that is correct. Next, third one I have is using aniline. So if I treat NH2 with NaNO2 HCl, I will get N2 plus and Cl minus, and with warm water I will get back phenol. This is important, this is important. And next one, the cumene process. This is very important because it is the commercial method. Okay, in this what we take? First we take isopropyl benzene, then take O2, then you add OO here, and then H plus and H2O, you will get phenol here. Okay, so please remember, this is important. And here with phenol, the byproduct that we get is acetone. Sometimes the question is asked about byproducts also, so you should remember that as well. Okay. Okay, yes, please note down this one. All of you take a screenshot again. Quickly take a screenshot, students. Quickly take a screenshot, then we will move forward. Okay, all of you take a screenshot quickly, then we will be moving forward. Okay, next, let's start with the reactions of alcohols. Okay, what all reactions we have alcohols for that? Just a minute. Okay, under reactions of alcohols, we have 2 types of reactions. Okay, one where there is cleavage of OH bond. Under that we have reactions with metals, esterification reaction, and acidity of alcohols. This is very important. Questions are asked from acidity of alcohols. Next, coming to cleavage of CO bond. So you can see that in ROH, right, alcohols are like this. So either this bond can break. Under that, what all reactions we will get? Reactions with metals, esterification reaction, and acidic nature. And to break, if this bond is breaking, then what all reactions we have? You have reaction with HX, reaction with PX3, dehydration, and oxidation. Okay, these are the reactions that we will see. Clear? So let's move forward. First one, where we are discussing cleavage of OH bond, or where OH bond is breaking. The first one is your reaction with metal. So if I react with metal, what I will get? RONA plus H2. Okay, H2 gas will form. RONA plus H2 gas. Now if I the esterification reaction I can do, ROH plus RCOOH, you will get an ester here. Okay, now esterification you can also do by taking anhydrides and acid chlorides. Okay, so what I am saying here, see, this esterification we can do by 3 methods. You can react alcohols with acids, okay, with acid chlorides, okay, and with acid anhydrides. Okay, all these three will react with alcohols to give you esters. First thing over reactions with metal, you will get RONA plus H2. Acidity of alcohols, we will solve questions and we will understand. In acidity of alcohols, you have to understand that electron withdrawing group will increase the acidity. Okay, fine. Now okay, next coming to where the reactions where there is cleavage of CO bond, means this bond is breaking. Okay, this bond is breaking. ROH is there, right? This bond is breaking. That reactions we will see. So the first one is HX. Okay, in that what will happen? RX will form. You can see ROH will be replaced with X, so that is RX. First one, okay, reaction with HX. Second one, we have reaction with PX3. This reaction we have already seen in the haloalkanes chapter. What will happen? OH will be replaced with X, so we will get RX. Next, reaction with H2SO4. Okay, if you just react with H2SO4, you will get dehydration. Okay, dehydration will take place and we will get alkene as the major product. And in dehydration also, what is the order for followed? 3 degree, 2 degree, 1 degree. Means 3 degree alcohols are more reactive than 2 degree, then 1 degree. Okay, okay, clear everyone? Students, check, take a screenshot here quickly, all my children. Thank you, Vasu, thank you, Vasu. Please take a screenshot, all of you. We will move forward. Take a screenshot, all of you. Yes. Okay, Kavya, polymers is deleted. Okay, polymers is deleted, no need to study. Okay, next let's move forward. That is cleavage of CO bond, that is oxidation of alcohols. How can we oxidize alcohols? So you can oxidize alcohols by using CrO3. Okay, that will convert primary alcohols to aldehydes, secondary alcohols to ketones. And similarly, PCC I can use to convert primary alcohols to aldehydes. And we also have copper at 573 Kelvin, which will convert primary alcohols to aldehydes, secondary alcohols to ketones, and tertiary alcohols to alkenes. Okay, clear? Yes. Okay, so students, please now take a screenshot here. I think there is no doubt here. All of you might be remembering all these reactions. Yes, yes. Renuka, we are solving questions. We will solve, don't worry. We are going to solve questions as well. Okay, we will be solving questions. Okay, next, moving forward, I hope all of you have taken this screenshot. Next, coming to quickly reactions of phenols. So we have a lot of reactions for phenols. Okay, first we will be talking about the acidic nature of phenol. Then you have esterification, electrophilic substitution reaction, Kolb's reaction, Riemer-Tiemann reaction, reaction with zinc dust, and oxidation. Okay, so all of you know this acidic nature. We have discussed what we have to study under acidic nature. If there is electron withdrawing group, acidic nature will increase. In esterification, just now how the aliphatic alcohols will undergo esterification, same way the phenols will also undergo esterification. Next, electrophilic substitution reaction. So this is important that we will see. So let us start here. Okay, okay, so the first one, if you see the first one here, we have reactions with metals. Okay, how aliphatic alcohols will react. In the similar way, phenols also react with metal. Okay, now if you see the electrophilic substitution reaction, this is important. Electrophilic substitution reaction, nitration. With dilute HNO3, you will get ortho and para products separately. With concentrated HNO3, you will get all the ortho and para positions occupied at the same time. Okay. Next, if I just use bromine water, all the ortho para positions are occupied. But if I use bromine with CS2, then you will get ortho and para products separately. Okay. Next, we have if you take Na, that is you get this OH with NaOH, you get RONA, means phenol ONA or phenoxide ion, and if you treat it with carbon dioxide, you will get salicylic acid. Okay, this reaction is called as what? Kolb's reaction. Okay, Kolb's reaction. Next, okay, so just take a screenshot here quickly. Take a screenshot quickly. All the reactions are important. Yes. Next, moving forward, if you take OH CHCl3 with aqueous NaOH O minus CHCl2 NaOH O minus. So first of all, what I am getting, if you take this one CHCl3 and aqueous KOH, you will, or NaOH, you will get benzaldehyde. And what is the name of this reaction? Let me see how many of you can answer. Can you tell me, students? Please put attention here and tell me what is the name of this reaction. What is the name of the first reaction? Anyone can tell me the name of the reaction? Yes, Manjula, absolutely correct. Ritesh, Anusha, no, Manjunath, see, it is not ITAD, it is Reamer-Tiemann reaction. Yes, all the way good, all are correctly answering. Okay, in ITAD reaction, those who are saying ITAD reaction, just let me clear. For ITAD reaction, you have to use CH3 in presence of CrO2, Cl2, CS2. Then you will get a complex and that gets converted to benzaldehyde, and this is your ITAD reaction. Okay, this is ITAD reaction. If I start with OH and I got OHCHO, that is salicylic aldehyde. Okay, not benzaldehyde, sorry, it is salicylic aldehyde. Okay, that is your Reamer-Tiemann reaction. Okay, and don't worry, we are also going to solve questions from here. Next, oxidation. If I treat phenol with zinc dust, you will get benzene, and if you treat it with Na2Cr2O7H2SO4, you will get benzoquinone. Okay, this is called as what? Benzoquinone. Okay, clear? So please take a screenshot of this one. Okay, then we will just, I'll be aside. Quickly, all of you take a screenshot and then we will move to the next question. Okay. Okay. Next, esterification, I have already explained. So if you take with acids, acid anhydrides or acid chlorides, you will get esters here. Okay. Now for this one, this is important. Question is asked here. If you take salicylic acid, this compound is called as salicylic acid with an anhydride, then what will happen? This OH will get converted to ester, OCOCH3, and this compound is called as aspirin or aspirin, which is used as a medical drug. Okay, so you have to remember the aspirin structure, and this reaction is very, very important. Okay. Okay. Next, coming to preparation of ethers. So under preparation of ethers, first method is what? If I take alcohols, okay, at 443 Kelvin, okay, alcohols at 443 Kelvin will give you ethers. That's the first thing. And for Williamson ether synthesis, what I can get? RO minus Na plus and R dash X. This will give me ROR dash. Okay, that is the Williamson ether synthesis. Here one condition you should remember, that this Rx must be a primary halide. Okay, it must be a primary halide. You should not take secondary or tertiary halides here. Okay, it has to be a primary halides. Okay, clear? Okay, next, chemical properties of ethers. Okay, so ethers, I want to discuss the chemical properties of ethers. Please listen very carefully. From here questions are asked again and again. Very, very important. You have RO, R dash. Okay. Condition number 1. If R and R dash are primary or secondary, then what will happen when you treat it with HI? Okay, the nucleophile will attack on the less hindered site. Less hindered site. For example, if I have CH3O, CH2CH3, okay, and you treat it with HI, then what will happen? The nucleophile I minus will attack on the less hindered site. Both are primary, less hindered. You can see this side it is less hindered, so I will get I on that side. So CH3I will form. So this bond will break like this. CH3I will form and H will be added here. CH3CH2OH. Okay, that's the first case. Okay, now second case is what? If one side is tertiary and the other group is primary or secondary. Okay, like for example, if I have CH3O, CH3, CH3 and CH3, and if I treating it with HI. Now this is a tertiary group, so whenever you find a tertiary group, the I will always go to the tertiary group. Here the mechanism followed is SN2 and here the mechanism followed will be SN1. So I will go to the tertiary side and the bond will break like this, and I will get here CH3OH plus CH3 whole 3 Ci. That's the third thing. The second thing. Next, whenever you have phenol ring, okay, suppose like this, at that time always add H to the phenol group. Okay, you will always get a product like this, that is phenol. Always we will get phenol and then I will get CH3I. Clear? These are the important things. Please remember. Yes. Once again listen, those who are having doubt, please listen, this is very important. Whenever I have ROR and you are treating it with HI, see first what happens. If you are treating it with HI, you will get one alcohol and you will get one iodoalkane. Okay, so but which one will give you alcohol and which group will give you iodoalkane, how to decide? You have to check both the groups. If both are primary or both are secondary, or one is primary, one is secondary, in all those cases SN2 mechanism is followed and the I minus will go to the carbon where there is less steric hindrance. For example, you can see this is primary, this is also primary. So I minus, you can see here only one carbon, here two carbon, more bulkiness is there, right? So I minus will go to the less bulkier side and I will get CH3I and this part will give me alcohols. Next, if I have one side there is tertiary group, okay, one side there is tertiary group and I have one side primary group or secondary group. Whenever tertiary group is present, I will always attack to the tertiary group. So I will get this I product and this one will form alcohols. Next, if you have phenol ring, okay, if you have one benzene ring and then OCH3, in that case always phenol will the product, means bond will break like this, OH will be the product and then we will have CH3I. Okay, is it clear this one? Hindered means where there is more bulk, means more crowdiness is there, that is called as hindered. Here you see there are two carbons, right? This I minus will have more difficulty to reach here because two carbons are there. So that is called as hindered or steric hindrance we call it. Okay. Now one more case is there. I am erasing this one. Okay. One more case is there, the fourth one, that is if you have, see like this, if this is there and we have this one, there is a difference. You are treating this one with HI and this one you are treating with HI. So now you told me, if I told you that O is attached to the benzene ring, then directly first one product I will get is phenol, definitely. Here no doubt, right? I hope no doubt in this case. But here you see in this type of condition what will happen, you can see this is also primary, this is also primary, right? Now this is also primary. Right, now you will tell that ma'am both are primary, so I minus will go to the less hindered side, and here I can see a very bulky group, here there is a less bulky group, so I minus will go to the less bulkier side, right? That is what the rule. No, see this carbocation which is formed here is a stabilized carbocation. Okay, stabilized carbocation because of this benzene ring. So in that case, if you have a stabilized carbocation on one side, okay, stabilized carbocation means in what case? Stabilized carbocation means it should be resonance stabilized. In that case, this bond will break like this, I will come here and I will get a product like this. Okay, I'll get the product like this. Okay, I hope this is clear. I hope this is clear, everyone. Students, please tell me if this is clear to all of you. Do tell me if this is clear to all of you. Is it clear to everyone? Okay, clear? Fine. So next we will, that is what we have discussed here. Okay, so you can see here, if I check this one, this is tertiary, this is primary. So what will happen? I will come on this side and H will come on this side. Next, phenol is gray, so definitely H will come here, I will come here. Now if you see this one, this is primary, this is secondary, so I will come on the less hindered side and H will come on the more hindered side. Okay, fine. Next we'll see electrophilic substitution reaction. So OCH3, okay, this is an electron donating group or it is ortho para directing group. So whatever groups you are adding, it will be directed to the ortho and para position. So if I have OCH3, what will happen? The bromine group will be added at the ortho position and the bromine group will be added at the para position. Okay, next if I have RCOCl, in that also you will have COR at the ortho position and you will have COR at the para position. Next, if you have RCl, AlCl3, in that case you will get OCH3 R at the ortho position, okay, and you will have OCH3 R at the para position. Next, nitration also you will get same thing, NO2 will be added at the ortho and para position, okay. Okay, now let's do question, okay. So students, now it's time for question. Let's see the first question here quickly. A compound C7H8O, okay, whenever you see carbon C7H8O means more than 6 carbon, definitely benzene will be present, is insoluble in NaSO3 but dissolved in NaOH and gives a characteristic color with neutral FeCl3 solution. So if anything is giving a characteristic color with neutral FeCl3 solution, that means it has a phenol group, okay. Phenol group is definitely present, okay. So that only in that case you will get a neutral FeCl3 solution will show positive test. So phenol group is confirmed, and I can see in option A there is no phenol group. So from the first line itself we can eliminate option number A, okay. Next, when it is treated with bromine water, compound A forms compound B with the molecular formula C7H5OBr3. So now we have just discussed, if I treat phenol with bromine water, it replaces all the ortho, para and meta positions, right. Now if you see here, OH is there, so ortho position is free and para position is free, so all of them will be replaced with bromine, right. So this can be the answer. Here if I see ortho position is blocked, so there will be no bromine here, there will be one bromine here and one bromine here. So I will get 2 bromo product, but in the question it is given that 3 bromo product is formed. Similarly here if I see, I will get bromine at these 2 positions but not at this position because it is already blocked. So C and D cannot be the answer. Answer has to be option number B, okay. So it is B, everyone, please correct it, it is B, okay. Next question, let's do the next question. Can we answer the next question quickly? You have phenol NaOH, you are treating it with A, then you are giving CO2H plus B, and then you are giving this compound, and Y is the major product. What is the compound here? Yes, Ayush, questions gets repeated in the from your previous year questions, definitely. Okay, this one many of you have already answered. So this is what? This is O minus Na plus, first one, okay. Then I will get B will be your OH COOH, that is your Kolb's reaction, and then acetylation of this OH will take place and we will get OCOCH3 and divided by and this COH, and this compound I told you to remember, question will be asked from here, so that is aspirin, okay. Next, moving to this question, this is also a very good question, please try this question all of you. Yes, okay. Mohana Pujari, ma'am, can you increase the volume? Okay dear, I will increase it. Okay, so next questions, all of you please read, the next question. Yes, please read the next question here and tell me the answer. Which options we can eliminate easily? See, 8.8 gram of monohydric alcohol. Monohydric alcohol means there is one alcohol, okay, added to ethyl magnesium iodide. Ethyl magnesium iodide. So first remember, what is the product when alcohols react with Grignard reagent? Okay, so in alcohol RO minus H plus will be forming, and in Grignard reagent plus minus is there. So what will be the product here? R dash H, okay, R will take this minus, will take this plus, and ROMGX. Okay, this will be the product for any Grignard reaction. Now if I see this one, so ethyl, this ET will take this H, right, this R is taking this H, so I will get what? Ethane plus ROMGI. Okay, that is the question. Now it liberates 20 to 40 centimeter cube of ethane. Okay, this much ethane is produced at STP. Now this monohydric alcohol, when it is oxidized using PCC, the alcohol, okay, here the question is like this, actually it is incomplete. When it is treated with PCC, it gives a positive tolerance test. Okay, gives a positive tolerance test. That means what? This group, this one which is giving a positive tolerance test, if I oxide, that means this must be one aldehyde group, right? This must be one aldehyde group which is giving you positive tolerance test. If this is giving you aldehyde, then this must be a primary alcohol. Okay, this must be a primary alcohol, because primary alcohols on oxidation will give you aldehydes, right? So I can see that which options I need to have a primary alcohol for this one. So I can eliminate option number A and option number C, because that is giving me, these are secondary alcohols. I hope this is clear. Once again, let's see. The alcohol, if you oxidize it, it gives you an aldehyde. Why I am saying it is an aldehyde? Because it gives a positive tolerance test. Now if this is an aldehyde, so this must be a primary alcohol, because primary alcohol on treatment with PCC gives us aldehyde. So primary alcohol means I can remove these two. Okay, now I am left with these two. Now what if I see what is the number of moles of ethane produced? Number of moles of ethane will be what? Given volume by molar volume, that is 20,400. Okay, so that is 1 by 10 or 0.1. 0.1 moles of ethane is produced. Now see, 1 mole of alcohol will react with 1 mole of Grignard reagent to give you 1 mole of ethane. If ethane produced is 0.1, then alcohol will also be 0.1. Right, the number of moles of alcohol will also be 0.1. Now we have number of moles is equal to given mass by molar mass, and number of moles is 0.1, and what is the given mass in the question? 8.8, right? And what is the molar mass then? 88 grams per mole, right? So out of these two options, we have to check which option mass is 88 gram per moles. Let me check with option number B, 2,2-dimethyl propane 1-OL. Okay, so it is 2,2-dimethyl propane 1-OL. Okay, so this is the formula, 2,2-dimethyl propane 1-OL. Can we check the molar mass here? 1, 2, 3, 4. 1, 2, 3, 4, 5. 12 5s are 60. Then I have how many hydrogen? 3, 3, 9, 10, 12 hydrogen. So 12, and then oxygen is 16. So if I add them, I'll get 88 grams per mole. So that is the molar mass here. So option number B is the correct answer. Okay, so option number B is the correct answer here. Clear? Okay, clear? Okay, just a minute. Next question. All of you please try the next question. Okay, please try the next question. Okay, you have to find the acidic order. So you have propanol. Always remember, first of all, that aliphatic alcohols. Please answer this question. You have to remember what? Aliphatic alcohols are less acidic than phenols. Okay, so phenols are more acidic. So now in phenols, if I have electron withdrawing groups, then they will be much more acidic. Okay, so if I see first one, propane 1-OL, it is a aliphatic alcohol, and all other three options are your phenols, right? So that is why propane 1-OL will be the least acidic. So one will be least. So I have only two options like that. Okay, this is not there, this is not there. Now if I just find out which is the highest one, I can get the answer. Now if you see here, there is 4-methyl, which is a donating group, and I have 3-nitrophenol and I have 2-nitrophenol. So whenever I have electron withdrawing group, always remember that if it is present at para position and ortho position, it will be more effective. Okay, para is more effective, then ortho, then meta. So if I see this one, out of 4th and 5th, okay, so if I just check 3-nitrophenol and 2-nitrophenol, so in 2-nitrophenol, this group is present at the ortho position, right? So it will be more acidic because the electron withdrawing group present at the ortho position. So which one will be more acidic? Fifth one will be more acidic. So I can eliminate this also. Option number A will be the correct answer. Okay. No dear, D is wrong. D is wrong. Why? Because 3-nitrophenol, it is present at the meta position. So whenever electron withdrawing groups are present, they should be present at para position, then they are very much effective. After that ortho, after that meta. Okay, meta will come at the end. Clear? Okay. Next question, A is the correct answer. Can we answer this question? Next one. I have given you solution also, sorry. Sodium phenoxide when treated with ethyl iodide, the compound formed is. So you can see the solution, sodium ethoxide when treated with ethyl iodide. So that will give you what? OC2H5 or phenitol. That is option number B here. Okay. Okay. Next. Okay, Nitin is saying, ma'am, D option, why it is wrong, not understood. So D option you see here dear, fourth one is given the highest one. What is the fourth compound given? Fourth compound is, see, this is fourth compound. What is fourth compound? 3-nitrophenol. Right? This is present at meta position, and this one, the fifth, that is your fifth compound, that is 2-nitrophenol, where it is present at ortho position. So whenever electron withdrawing groups are present, if they are present at para position, they are most effective. Or after that comes nitro, and after that comes meta. Okay, because nitro group here withdraws the electron by -R, and this withdraws by -I effect, right? So minus R is more powerful, so that is why this one will be more acidic. Okay, clear? Okay, next. Again you have to find para-methoxyphenol, para-methylphenol and para-nitrophenol. Very easy question. Para-nitrophenol, para-methylphenol and para-methoxyphenol. Please do it quickly, students. First we have para-methoxy. This is para-methoxy, electron donating group and donates by +R effect. Next I have para-methylphenol. Okay, I have para-methylphenol. Here also it is electron donating group, but it donates by +I effect. And next one is para-nitrophenol. Okay, para-nitrophenol. And this one here it is electron withdrawing group and withdraws by -R effect. So can I get the answer for this one? Can we get the answer for this one? D, many people are saying. Yes, I think D is the correct answer. Definitely you can see here, first of all, electron withdrawing group is there, so that will be more acidic. So 3 will be more acidic. I can eliminate these two. Now here you see donating, right? Both of them will decrease the acidity, but +R effect is more prominent, means it will donate more, it will decrease also more. So the one will be the least acidic, then option number D here. Yes, all of you are saying D, absolutely correct. Very good. Next question, just now we have discussed cleavage of ether, very important question. I have CH3O, CH, CH3 and CH3, right? So this is it tertiary? It is not tertiary, right? It is primary and this is secondary. So when you have primary and secondary, what will happen? I will go and attach to the less hindered side. So this is less hindered side, so the bond will break like this. Okay, bond will break like this. I will come here and H will come here. So I will get CH3, CH3I plus CH3 whole to CHOH. Yes, again D is the correct answer. A is not answer. A is not the correct answer. If this would also be CH3, okay, this group would have been CH3, then it is a tertiary group. Then I will attack here and CH3OH will form, right? But this is a secondary group, and whenever it is either primary, secondary or anything, you have to take it as SN2 mechanism. Okay. Next, the best method to prepare 3-methyl-butane-1-OL from 3-methyl-but-1-ENE. You have 3-methyl-but-1-ENE, okay, 3-methyl-but-1-ENE and 3-methyl-but-1-OL. 3-methyl-but-1-OL. How can you prepare this one? Just now we have discussed this reaction. Everybody should be able to answer. You want to add water according to anti-Markovnikov's rule. We have seen that we can add by two methods. One is H plus H2O and another is B2H6 H2O2 OH minus, right? So this one will give me anti-Markovnikov's rule, right? So that is the best method, hydroboration oxidation, that is option number C. Now see, this is also correct, okay? Addition of HBr in the presence of peroxide followed by the treatment with aqueous NaOH, this method is also correct. But the question is asking best method. Okay, best method means here you see, here we have two-step reaction. First I will add HBr, then I have to add aqueous NaOH. But this is a single step reaction. Only by adding this one reagent I can get the answer, right? So that is why the best method is option number C. Okay. Okay, next we will go for next question. So here you have this group is given, okay, and you are treating it with NaBH4 and with LiAlH4. X and Y respectively are. Okay. Okay. Can we check now the answer for this one? Sanidhi, if you do all of them, you can easily score 40 plus, okay, 45 plus to 40 to 45 plus you can easily get. Okay, next question, all of you please answer. So now you see, if I treat it with NaBH4, this one will get reduced to CH2OH, okay, the double bond will not be affected. So I have this option in this one. Here the double bond is affected, that is not there. Here also the double bond is affected, that is also not there. So I can have either this one or this one. Next I have LiAlH4. In LiAlH4 what happens? The double bond is also reduced. So here the double bond is reduced, and here also, one second. Okay, here there is no OH, right? So this option is also incorrect. So option number A will be the correct answer. Okay, A will be the correct answer. Okay, A will be the correct answer. In NaBH4, CH2 is not reduced, so that is why B is eliminated. Okay, yes. Next, alcohol that gives turbidity on reaction with concentrated HCl and ZnCl2 only on heating. So here if you remember, if I have tertiary alcohol and if I react it with concentrated HCl and ZnCl2, reaction will happen immediately. Okay, secondary alcohols will take 5 minutes. Okay, and primary alcohols will react only on heating. Only on heating it will react. So which is a primary alcohol that will react only on heating? Yes, that is option number A here. Okay. Next we'll move to aldehydes and ketones. Okay, quickly let us see the preparation methods of both aldehydes and ketones. First of all, by oxidation of alcohols, we have already seen what are the oxidation methods that we can use or reagents that we can use for oxidation. We can use PCC, we can use CrO3, or you can use copper at 573 Kelvin. Okay, primary alcohols will give you aldehydes and secondary alcohols will give you ketones. Okay, that's the first thing. Next, dehydration of alcohols, that is using your copper at 573 Kelvin, is called as the dehydration of alcohols. Next, from hydrocarbons by ozonolysis. What we do in ozonolysis, you just take one double bond, okay, and if you just treat it with O3, Zn and water. In that case, what will happen? The double bond will break and you will get two, like if whatever group is there, here oxygen will be added and here oxygen will be added. That is your ozonolysis. Next, what will happen? Hydration of alkynes. In hydration of alkynes, what we do? So suppose I have a triple bond. Okay, so let me just show you this one. So first one, you can see the first method from alcohols. Okay, the second method is from dehydration. The third one that I told you is ozonolysis, and fourth one. Here first what happens? H plus and OH minus are added following Markovnikov's rule. After that there is tautomerization. Like for example, you see I have propine. Okay, suppose I have propine. Okay, propine is there and you treat it with H2O and Hg2 plus. Okay, so what will happen? H and OH will be added following Markovnikov's rule. So carbon having less number of hydrogen will take OH group. So this carbon is having less number of hydrogen, so that will take OH group, and this one will take this group. right? So this will be the product form. Now after that what happens, we take tautomerization. In that what will happen, this group will get converted to a carbonyl group, okay, like this, and this one will become CH3, okay. So this is called as your reactions using alkynes, okay. Okay, clear? Clear. Okay, next, just a minute. Yes, so these are the methods by which we can prepare both aldehydes and ketones, okay. Now we will see the methods for preparation of only aldehydes, okay. If I just want to prepare aldehydes, not ketones, okay. So what all reactions I have, you can see here. First is from acyl chlorides, okay, that means RCOCl, okay. On RCOCl, if I take H2 palladium barium sulfate, okay, what will happen, this chlorine will be replaced with RCOH. Can we tell me the name of the reaction? Anyone can tell me the name of the reaction? Yes. Can you tell me the name of the reaction? Yes. Rosenmond, yes, very good students. Rosenmond reaction is the correct answer here. Next, from nitriles and esters, if I have RCN, okay, RCN, in Stephan reaction what do we use? So I will just show you all the reactions. You can see here, this is the complete reaction chart. So the first one here is Rosenmond reaction with RCOCl H2 palladium barium sulfate, you will get RCHO, okay. Next, RCN, if I have RCN, okay, you can use SnCl2 and HCl to get RCOH, SnCl2 and HCl. First I will get a imine or imine, then you can take it as H3O plus, you will get RCHO, okay. What is the name of this reaction? This is your Stephan reaction, okay, Stephan reaction. Next, RCN, if you treat it with dibal H, there is a reagent called as dibal H, that if you treat, that also will give you aldehyde. Next, with esters also, if you treat dibal H, you will get aldehydes. So this is your second method. From nitriles and esters, we can use dibal H. The third method is your from hydrocarbons, or you can have toluene, CrO2, Cl2, CS2. This reaction is called as your Itard reaction, okay. Next, you can also take toluene with CrO3 and acetic anhydride, that will give you a complex, and then you can hydrolyze it to give you aldehydes. And next one, this last one is your Gattermann-Koch reaction. If you take benzene, COHCl in anhydrous AlCl3 and CuCl, that will give you RCHO. And next one is your side chain reaction, okay. In side chain reaction, what we do, CH3 you treat it with Cl2H nu, you will get CHCl2, and with H2O and 373 Kelvin you will get RCHO, okay. Okay, clear? Yes, so there was, these are the reactions, so please take a screenshot of this one, everyone. All of you please take a screenshot quickly, and then I'll move aside. Please take a first screenshot, everyone. Okay, I can see some doubts in the previous question. Let me go back. Okay, this question I have I think Chida Junjaya, sorry if I am pronouncing your name incorrect, but has a doubt, is cinnamaldehyde double bond reduced by LH4? Why? Please tell. Okay, so dear, listen here, if you have any time, if you have C double bond OH and the next carbon is double bond, means there is a conjugation, okay. If there is a conjugation, in that case LAH can reduce the double bond, only in that case. Generally LAH does not reduce the double bond, but if there is a conjugation in the double bond, as you can see there is a conjugation here, so that will be reduced by double bond, okay. LiLH4 can reduce that double bond. Clear? Yes, I hope this is clear for everyone. Okay, now let's move. Okay, fine. Okay, next we have preparation of, okay, some students are asking for break. Okay, So students, just tell me how many of you need break. If you just need a break, we can have a 5 minutes break here. Okay, just those, if I see majority of students asking for break, then we'll take a 5 minutes break. Okay, otherwise we will start. Nope, no break, no break. Okay. Okay, so I'm giving you just 2 to 5 minutes break. So in that I will be taking your questions. After 5 minutes we will resume the class. Okay, at 10:26 it is now. At 10:30 I will resume the class. Okay, 10:30 I will resume the class. Till now let's discuss your doubts. Okay. Okay, I can put all your doubts here. Okay. Okay, those who are telling no doubts, so students just wait. We will take some more 4 minutes only. Okay. Yes, Ayush, we have exam, right? We cannot take more than 4 minutes at this point of time. Yes, Lavanya, we have Woods reaction and fatigue reaction. Definitely it is also there. 10:30 Shritan, 10:30. Yes, Uday, you will get the PDF after the class. Okay, in WhatsApp channel it will be uploaded. I think there are some PDFs have been pending to be uploaded. So the top 100 questions and the complete revision part 1 and complete revision part 2 will be uploaded from my side in the WhatsApp channel. Okay. Parvati, yes, definitely you can secure 35 plus. Definitely, easily you will get it. Okay. Okay. Talag 78, sorry ma'am, can you explain the reaction of NaBH4 in that question? So dear, NaBH4 will reduce only the aldehydes to alcohols. Okay, so if you see the previous reaction, that is aldehydes to alcohols, this question, right? In this what will happen, this aldehyde part, this is actually C double bond OH, so NaBH4 will reduce this aldehyde directly. Okay, so I will get here C6H5 CH double bond H CH2OH. Okay, so that is why that Y will be this option number A. Okay. Okay. Mr. Strange, hall print you can take in black and white also, color print also. There is no such rule given. Okay, you can take in any one, that is fine. Okay, next what is there? Organic chemistry, see dear, total 60 marks, right? You can expect 40 plus marks, like almost 42 marks from your PU2 syllabus. Okay, and in that solutions, electrochemistry and kinetics will be around 15 marks you can say. Okay, and then 10 marks will be I think not 10 marks, sorry, 6 marks will be your inorganic. So I can say physical plus inorganic, total will be around 20 to 22, and the rest 10 or 12 marks will be your organic chemistry. Okay, out of PU2 syllabus I am telling. Okay, how to join WhatsApp channel? Lucas, the link will be given in the description section. You can take there and join the WhatsApp channel. Okay. Shri Neha, yes, we will do inorganic. Let's try to complete the organic first, then inorganic. We have only 2 chapters, right? We'll complete it fast. Okay. Yes, inorganic is there, Shri Neha. Okay. Topper monkey, ma'am, teach again. Which one, dear? Which one you want me to teach again? Please tell me. Yes, Shivakumar S, in our WhatsApp group the PDF will be shared. Please don't worry. Curious Kitty, instructions page printout is not needed. Okay. Yes, Lavanya, biomolecules also I will do. Okay. Sagar S, if the questions comes out of the syllabus, just attend any of them, it will not be considered. Means last year, according to last year what happened, you know, so those out of the syllabus questions were discarded. So same year will happen, same thing. So if you are getting any out of the syllabus question, don't leave any question, because you have no negative marking. So please attend all the 60 questions and comes. Okay. Yes, time's up. Yes, time's up for everyone. Sanskriti, in my last live revision video, Sanskriti, you can see, just go to our channel live session. The first live that we did on physical chemistry, I have discussed all the formulas there. You can watch that. Okay. Yes. and whatever your questions regarding the documents required and whether this is allowed, not allowed, I am making a detailed video on what all things you should carry. In the morning itself you will get that video, so please don't worry, now don't ask this question, I will make a detailed video on that. Okay, yes. Okay, so times up students, let's get started here. No more questions, let's get started. Okay, let's get started everyone. Come back to the study zone. Okay, please just have little bit of water. See, I'm also thirsty, I'm not yet taken water, so just have your water and please do some stretching. Okay, let us do some stretching together. Okay, all of you, let's do slight stretching your body and mind and everything, and then come back and study. Okay, yes, are we ready now? Yes, Shritan, I will have. Okay, so first do little bit of, all of you just get up from your chair, table, bench, wherever you're sitting, just do little bit of your stretching exercises and let's come back, right? Okay, let's get started. So now we have discussed the preparations of only aldehydes, right? What were there? We have Rosenbaum reaction, we had Gattermann-Koch reaction, we have Stefan reaction, and there are some methods to prepare only aldehydes. Similarly, we have some methods to prepare only ketones. Okay, the same thing we can use from acyl chlorides, then from nitriles and from substituted benzene. So how can we do? So if I have first one, that is from acyl chlorides, R2CD, okay, that is called dialkyl cadmium. In this what will happen, this Cl group will be replaced with R group. Cl group will be replaced with R group to give you this benzene product. Okay, next with nitriles, if I want to do with nitriles, I have to take Grignard reagent. Okay, in Grignard reagent what will happen? Mg plus and this is minus, right? This is plus and this is minus. So this is again minus and this is plus. So this C6H5 will attack here. MgBr will attack on the nitrogen. You can see this one. And now if I do hydrolysis, this group will get converted to your aldehyde group, sorry, ketone group. Okay. Yes. Next, we will have here chemical reactions of aldehydes and ketones. There are so many reactions, so I will just discuss them. Okay, all of you might be remembering all of these reactions, but let's have a quick recap of chemical reactions of aldehydes and ketones. The first reaction is nucleophilic addition reaction. Under that we have 5 addition reactions: addition of HCN, addition of NaHSO3, additions of alcohols, addition of Grignard reagent, and addition of ammonia and its derivative. Okay, first reaction is addition reaction. Second one is reduction reaction. So we have first one reductions to alcohols, and then we have reductions to hydrocarbons. Reductions to alcohols, what all reagents we have, can we tell? How can we reduce carbonyl compounds to alcohols? We have NaBH4, we have LiLH4, you have these two reagents we use. Now reductions to hydrocarbons, there we have Wolff-Kissner reduction and Clemmensen reduction. Next, coming to oxidation, Tollens test, Felling's test, and oxidation of methyl ketones. Tollens test, we use silver mirror. Felling test, you use copper, and oxidation of methyl ketones, that is your iodoform test. Next, alpha hydrogen reactions are aldol condensation and cross aldol condensation. Other reactions, we have Cannizzaro reactions and electrophilic substitution reaction. Okay. Okay, yes, Chandrakala, almost not come, before that we will finish, but it will become almost up to 12 o'clock. Okay, so now if you see, you can see the addition reactions here. Okay, addition of HCN, the first one, if I take addition of HCN, what will happen? OH and CN will form. This is called as cyanohydrine. Okay, this is called as cyanohydrine. Next, addition of NaHSO3, that will give you OH and SO3Na. Addition of RMGX, Grignard reagent. So what will happen? You can see this is minus, this is plus, this is minus, this is plus. So R minus will attack here, O minus will take this one, and if you do hydrolysis, we will get alcohol. So first we saw addition of HCN, addition of NaHSO3, addition of Grignard reagent, addition of alcohol. This is important. Under addition of alcohol, first I will get hemiacetal. Okay, hemiacetal, where we have OH and OR attached. Then after that OR and OR will be attached, that is your acetal, if you give excess of alcohols. And next one, ammonia and its derivative. In this what will happen? So in ammonia and its derivative, see what happens. You have like this, okay, and you have one ammonia and its derivative. In this H2O is removed and we get a compound like this. Okay, and in this we have different type of Z values. If you see the table, in different types of Z value we have different derivatives. Okay, so you have to remember some of them, very important. First one here is hydrazine, okay, then phenyl hydrazine, 2,4-DNP. okay, these are your important compounds. Its addition you should remember. Okay, ammonia and its derivatives. Okay, next coming to reduction reaction. So reduction, I have already told you, we have reductions to alcohols, right? So if I just use LiLH4 or NaBH4, I will get CH2OH. And if I want to reduce to hydrocarbons, we have to use ZnHg and HCl, which is your Clemmensen reduction. Okay, this is your Clemmensen reduction. And we have here, that is your Wolff-Kissner reduction. Okay, Wolff-Kissner reduction. Clear? Next we have oxidation reaction. So under oxidation we have Tollens test, Fehling test and oxidation of methyl ketones. So if you see here, if you take one aldehyde and you use Tollens reagent AgNH3 plus OH minus, you will get RCO minus plus Az. That is a silver lining is formed on the test tube. That is your Tollens test, right? This is your Tollens test. Now if I have Fehling's test, copper with alkaline medium, that will give me RCOO minus, which is a Fehling's reaction. Okay, Fehling's reaction. Clear? Now coming to next one, that is your methyl ketones. Where is it? Yes, this one. So any carbonyl group, if it is having this COCH3 group, okay, this remember, COCH3 group should be present, or you should have RCOH CH3CHOH. okay, this group should be present, CH3CHOH. If these two groups are present, then if you treat it with NaOH, or I can write it as I2NaOH, then what will happen? This bond will break, this one will get converted to CHX3, and generally we take iodine here and we get CHI3 here, which is a yellow precipitate. Okay, and the rest part, that is RC double bond O, gets converted to the acid. So this is a very important reaction. Wherever we have this CH3CO group, I will get methyl group. Okay, okay. Sagar S, we will not, this is what we are revising, but if you people want, we can make, but we have not anything planned like that to have a revision video in the morning. Okay, we can make it if you people want. Okay. Next, moving to aldol condensation. So see, aldol condensation, nothing you have to do. I will tell you a very easy and a simple trick that you have to follow. Okay, so first of all, remember that for aldol condensation, you need to have an alpha hydrogen. Reagent required should be dilute NaOH or dilute KOH. Okay, now what is alpha hydrogen? Means the carbon next to the carbonyl group. For example, this is there. Okay, this is your alpha carbon. Okay, carbon next to the CO group. Now this carbon, if it is having an alpha hydrogen, if this carbon is having hydrogen, then it will undergo aldol condensation. Now how to write the product of aldol condensation? Suppose I will tell you CH3CHO is there and it is reacting it with dilute NaOH, write the product. Okay, now what you have to do, whatever reactant is given, just write down it one above the other. Okay, just write down like this. Okay, 2 times you have written. Next, what you have to do, connect the alpha carbon to the carbonyl carbon. Okay, connect the alpha carbon to the carbonyl carbon. After that, remove one hydrogen here. Like see, you are connecting this one bond. Let me just tell you once again. Wait. Okay. Trick, all of you please listen the trick. It will be very helpful and save your time in the exam. First, you are connecting a bond here. Okay, alpha carbon to the carbonyl carbon. If you are making a bond, one bond will break, so this bond will break. Okay, next what you will do, you will remove one hydrogen from here. This is becoming CH2, so one hydrogen will be added here. Okay, so what I will get the product, CH3C, I started from here, CH3, then CHOH, right, OHH. Next I have CH2, next I have C double bond OH. Okay, this is if only dilute NaOH is given. Now if heat is also given with that, what I will do, you will remove this OH and put a double bond here. Okay, yes, clear everyone? This trick is clear to all of you? Okay. Okay, next we have cross-aldol condensation. In cross-aldol condensation, you take different aldehydes, right? I have taken here, if you see, here I have taken similar aldehydes, right? But if you take different aldehydes or one aldehyde and one ketone, that is called as cross-aldol condensation. Next, Cannizzaro reaction. Here what is there? Condition is no alpha hydrogen and we use concentrated NaOH solution. Okay, that's the two things. And if you have like this, a group like CHO, you will get one oxidized product and one reduced product. Means CHO will get converted to COO minus Na plus and CH2OH. Okay, so this is what the two products that will form. Okay, Shreya, okay, I am trying to increase, okay, I will try to increase the volume. Next, electrophilic substitution reaction. So remember your aldehyde groups, okay, these are your electron withdrawing groups and they are meta directing groups, okay, meta directing. So if I do nitration, means concentrated HNO3 and concentrated H2SO4, then what will happen? The NO2 group will be added at the meta position. Okay, so similarly you can do chlorination, Friedel-Crafts alkylation, acylation, everywhere the substituent will be attached at the meta position. Okay, okay, next we will see questions now. These are, let's solve quickly the questions from here. Yes, Anjana, while doing questions I will give you. Okay, next let's start here. Try this question, all of you. All of you please try this question. Yes. So now you see that this CO group is reduced to CH2 CH3, right? It can be either Wolff-Kissner reduction or your Clemmensen reduction. Now here you see Clemmensen reagent is also given, Wolff-Kissner reduction is also given. Then how to do it? You have to check the other group. Now see, this is alcohols are acidic in nature, right? So this is acidic in nature. So in the medium we have to take a base. Here you see the medium is acidic, here you see the medium is basic. So that is why we have to take a basic medium. So option number A here. I hope this is clear. Why not B? Why not B? Because this is an acidic medium. Acids, alcohols are acidic in nature, so you should provide a basic medium. Okay, so that is why I have to provide not an acidic medium, rather a basic medium. Okay, next, order of reactivity. Okay, here you should know what things, that aldehydes are more reactive than ketones. Okay, and reactivity, okay, reactivity is inversely proportional to steric hindrance. Okay, means if the molecule is very bulky, reaction will be less. Okay, if molecule is small, then the reaction will be bigger. First, aldehydes are more reactive than ketones. So can I see answers here from everyone? Answers, yes. So now you see this is an aldehyde, right? What I can see, this is an aldehyde, this is a ketone, this is a ketone. So definitely aldehyde will be more reactive. So 2 will be more reactive, only one option is there. So option number C here. But what else I can see about 3 and 1? See now, see these are small groups, methyl groups are present. Whereas these are big benzene rings are present, big groups are there, that means reactivity will be less. So that is why after 2 there will be 3 and then there will be 1. Okay, yes. Okay, next here, okay, you have to predict A, B and C. So what you will react with HgSO4 and H2SO4 to get acetaldehyde? PCC will give you, acetaldehyde is what? Ethanol, right? Ethanol. So what will be the reaction here? Anyone? Okay, just let me try holding the mic and speak. I hope it is audible now. Is it audible? Yes. Okay, all are saying C here. The answer, yes. First one, HgSO4, H2SO4 has to be ethyne group, right? So I can eliminate option A and B. Next, PCC, so that has to be ethanol. So I will eliminate option number D, option number C here. Okay, that is correct. Next question, all of you please try quickly. C6H5Cn with SnCl2 plus HCl and H3O plus. Okay, what is this reaction called as? What is this reaction called as? Yes, what is the reaction called as here? B, many students have already answered. Yes, that is your Stefan reaction. So the first one is Stefan reaction. Only one answer is there. So option number B. And after that, you take concentrated NaOH or KOH. That is Cannizzaro reaction. So option number B here. Okay, next can we see what is the reagent? Again, very important question. You see COCH3 is getting converted to CH2CH3. That means that it has to be a Wolff-Kissner or Clemmensen reduction. But again, I can find OH in the medium, right? If OH is present, that means it is an acidic medium. You have to give a basic medium, right? So that is why option number D here, okay? Yes, option number D, okay? Why C is coming? C, students, C will come if you are reacting, if you are converting this one to alcohols, then NaBH4 is required. But we are converting it to hydrocarbon. So it is Wolff-Kissner or Clemmensen reduction. Okay. Next question. Can we answer next question? Acetone, C3H6O is there. First you have to do aldol condensation. Then you have to treat it with Cl2NaOH. Yes, very good question. Can everyone try this question? Yes, B, we are getting the answer. Okay, first let me do the aldol condensation. I told you how to do aldol condensation. Acetone is there, right? So CH3CO, CH3. What is the trick? We have to write acetone once again at the bottom, right? Next what I will do? I will connect this alpha carbon to the carbonyl carbon and this bond will go, okay? And after that you will remove one H here and you will add one H here, right? So that is first product. Now when condensation is given means double bond will also form. So here there is a formation of double bond. This OH will be removed and H will be removed and a double bond will form here. So what will be the product here? CH3, then this carbon, okay? Then it also has a CH3 group. Okay, then we have a double bond, okay, then we have CH, then we have CO and then CH3, okay. After that, this is your X, okay, this is X. Next, you are treating with NaOCl, that is your iodoform reaction or chloroform reaction. What will happen? This bond will break and this one will get converted to CH3, okay. Then you have C double bond CH, COO minus Na plus, okay. So what I will get here, which option, or it can be further hydrolyzed to get you CH, okay. So I need two CH3 groups, so this is not there, this is also not there. Yes, this is there and this also can be there. Next what I have after to this carbon, CH and COH, so option number D here. Yes, all of you are giving correct answer. Lavanya, why liquid ammonia is used? So dear, liquid ammonia is used if that is the first where it is used is if you means there are I'll tell you the reaction. So suppose you have HBr, okay, HBr, okay. So if I want to remove this HBr, first I will use alcoholic KOH, okay. So that will give me CH double bond Br, okay. Now again if I want to remove HBr, I should not use alcoholic KOH. At that time you have to use sodium liquid ammonia, okay. That is where it is used, okay. Clear? Yes. Next question here will go to carboxylic acid. Quickly let's see the preparations of carboxylic acid from alcohols and aldehydes. So if you oxidize primary alcohols, if I use KMnO4 or K2Cr2O7, okay, these are the oxidizing agents which can oxidize primary alcohols to acids. And for aldehydes, what all things I can use? You can use Tollens test and Felling's test, okay. From alkyl benzenes, here also I have to use alkaline KMnO4 and KOH solution, right? That will give me from alkyl benzenes. From nitriles and amides, simply you have to treat or hydrolysis. Nitriles are CN. If you do H3O plus, you will get acids. Next, from Grignard reagent, if you treat Grignard reagent with carbon dioxide, you will get acids. From acyl halides and anhydrides, if this one and if you do hydrolysis, here also we will get, and from esters as well, okay. So I will show you all the reactions, do not worry. Krishna Mahuli, ma'am, can you explain aldol condensation once? Okay dear, let's once again do. So the question was from acetone, okay, if I treat it with acetone. So just write down acetone 2 times, okay. Next what you have to do, you have to connect the alpha carbon to the carbonyl carbon. Okay, alpha carbon to carbonyl carbon you have to connect. Now when you are forming a bond, you have to break one bond here. Okay, next you have to remove one hydrogen from this carbon, that is your alpha carbon. Remove one hydrogen and add that hydrogen here. Okay, now if you have added the hydrogen, this is the aldol product. Now aldol condensation means what? You are heating it. When you heat here, what will happen? There will be a double bond formation here, and if there is a double bond formation, this OH and one of this H will be removed. So what will be the product? You will get CH3. Okay, then you will get this carbon, and this carbon is having another CH3, then double bond CHCOCH3. Okay, that will be the product. Okay, yes LV, you will get the notes of this class. Okay, so let us start with the preparation methods of that is your acids. So the first one is from alcohols, right? Primary alcohols, you can oxidize with alkaline KMnO4, CrO3H2SO4, you will get acids. Second one is from benzyl or hydrocarbons, benzene with CH3 group, you have to use KMnO4, KOH and H3O+. Next, third one is from nitriles. So if you just treat it with water, you will first get amides, and then amides on hydrolysis will give you acids. Okay, next fourth one is from Grignard reagent. Grignard reagent with carbon dioxide will give you RCOMgX, and then H3O+ will give you acids. Next we have fifth one is RCOCl. Here if you just treat it with water, you will get RCOOH, and the next one is with esters, and esters if you treat it water, you will also get acids. Okay, yes. Okay, okay, so please all of you just check this one, just take a screenshot of this one, that we will be doing. After that we will go to the exam, we'll go to the questions. Okay, Ravi, what do you mean by BP? Can you just elaborate BP? Srihari, aldehydes are more reactive because aldehydes are less sterically hindered. In aldehydes, one side is hydrogen, right? So it is less sterically hindered, so that is why they are more reactive. Okay, let's go to questions now quickly. So next we have chemical reactions of acids. Okay. Okay, chemical reactions of acids. The first one is acidic nature. Here also you should know that electron withdrawing group will increase the acidity. Reactions with metals and alkalis, that is also there. Like how alcohols used to react, you will get salt plus hydrogen gas. Next we have anhydride formation. Then we have esterification, reactions with PCl3, PCl5, SOCl2, reactions with ammonia. Then you have reductions, decarboxylations, and halogenation and substitution. Okay, so in acids the reactions are categorized into four parts. First where there is OH cleavage, then there is where there is CO bond cleavage. In that we have four reactions: anhydride, ester formation, reactions with PCl5, PCl3, SOCl2, and reaction with ammonia. And then where the reaction of COOH group is involved, that involves your reduction and decarboxylation, and the reduction where this R part is involved, that is halogenation and substitution. Okay, yes, Lavanya, we will do biomolecules. Okay, so you can see here that, just a minute. Okay, so you can see here in acidic nature, what will happen? If I have electron withdrawing group, acidity will increase. So what are the electron withdrawing groups? CF3, NO2, CNF, chlorine, bromine, iodine, and phenol. Okay, so these are the electron withdrawing groups, and they will increase the acidity. Next we have here reactions with metals and alkalis. So if you see RCOOH, it can react with sodium, NaOH, and NaHCO3 to give you salt. And next we will have this one, cleavage of CO bond. So here we have these four reactions, right? Anhydride formation, esterification, reaction with PCl5, PCl3, SOCl2, and reactions with ammonia. This is very easy, so let us quickly check this. So you can see in anhydride formation, what is the reagent you have to use? P2O5 heat or H plus and heat. Two acids group will be there, H2O will be removed. Okay, so that is why we will get one anhydride formation. The second one is your ester formation. In that also you take H plus, then dehydration will take place and you will get esters. Third, with PCl5, PCl3 and SOCl2, this OH group is replaced with chlorine group. Okay, that is there. Okay, next we have here, that is cleavage of CO bond. Okay, just a minute. Yes, next we have reactions involving COOH group. Okay, so there I have reductions and decarboxylation. So for reduction, what I can do, LiAlH4 ether you can use, that will reduce this acid groups to alcohol group. Okay, and next we have decarboxylation reaction, NaOH and CO, that will reduce this to RH plus Na2CO3. Okay, decarboxylation reaction and this reaction. Next we have reactions of hydrocarbon part. This is very important reaction, HVZ reaction. You have to use X2 and red phosphorus. Okay, those are asking for boiling point. Yes dear, I will explain. Just please wait for some time. Let me complete this. I will come back to your doubt. Okay. Okay. Next we have HVZ reaction. In that H is replaced with X2 and red phosphorus. This alpha hydrogen is replaced with X. Okay. And we have the electrophilic substitution reaction. So COH group is also an electron withdrawing group. So it is also meta directing group. So if you do bromination, at the meta position bromine will come. If you do nitration, at meta position the nitration will take place. Okay. Clear? Okay. Next. Okay, now let's do questions, students, from this one. Please all of you start solving these questions. Okay, so just let me talk about the boiling points here. So alcohols, then we have ethers. Okay, Lavanya has asked alcohols, ethers, aldehydes, ketones, carboxylic acids and hydrocarbons. Okay, so carboxylic acids will have the highest because they can form more hydrogen bonding. After that we have alcohols. Okay, after that we have aldehydes, ketones, then ethers. Okay, and then we have hydrocarbons. Okay, fine. Now please answer the question that is given here. Yes, the organic compound A and B react with sodium metal and release hydrogen gas. A and B react with each other to give you ethyl acetate. A and B are. Can we guess the answer here? Yes. What is the answer here? Yes. Now you see, we need ethyl acetate, right? Ethyl acetate is an ester group. What is the formula of ethyl acetate? CH3COOC2H5, right? That is ethyl acetate. So I need one alcohol and one acid. So that has to be acetic acid and ethanol. So option number A here. Okay, this one will give you 3 carbons. I need total 4 carbons, so that is not there. This one will give me 1, 2, 3. This is also 3 carbon. Here I will get 3 carbon. So I need 4 carbons. So that is why option number A here. Okay. Next one here. Can you answer this one quickly? X is there and you have to treat it with something to give you CH3COH. Then with Y it gives you CH3 whole 2O. X and Y respectively are. Yes. Can we have something here? Okay, you can see aqueous NaOH you are using, right? That must be what? That must be a aqueous NaOH and this one, and here we have Y. So first of all, Y, if you see, this is anhydride formation, and for anhydride formation I need P2O5, so that is why option number B is the correct answer. And if you take CH3CN and do hydrolysis, you will get CH3COOH. Okay, option number B here. Yes. Next question. Next question, CH3CnH2O, and then you have excess of Cl2, red phosphorus. Very good question. Can we try this one? So first identify A. CH3Cn with water will give you, hydrolysis of cyanides will give you acids, right? So that has to be CH3COOH. This is not there and this is also not there. This is also not there. So directly option number A. right? And if you see excess of Cl2, so all the alpha hydrogens are replaced with chlorine group. That is your HBZ reaction. Next, CH3COH with lithium aluminium hydride, and then you are treating with H3O plus. Okay, so what will be A here? This acid will be reduced with LiAlH4 to give you what? Alcohols, right? So I will get alcohols here, C2H5OH. This is your ester. This is wrong, and this is also wrong. I will get C2H5OH. That is your alcohols. Next, alcohols and acids will react to give you esters. So that is why option number D. Shamant, we will take another half an hour to complete, most probably. Okay. Next, the relative acidic strength of benzoic acid, orthotolveric acid and paratolveric acid in the decreasing order. So you have benzoic acid, okay, you have benzoic acid, then you have orthotolveric acid, okay, COOH, and orthotolveric acid, that is CH3, and then you have paratolveric acid, okay, in the decreasing order of the acidity. Now if you remember this CH3 groups, okay, CH3 groups are what? Electron donating groups, so they will decrease the acidity, okay. So definitely benzoic acid is most acidic, right? So just a minute, benzoic acid, orthotolvic acid and paratolvic acid, okay. I think the options are little bit incorrect here, okay. The first, okay, fine. So listen, remember here there is something called as ortho effect, okay. According to ortho effect, what happens? If there is any group present at the ortho position, they will increase the acidity always, okay. If any group is present at the ortho position, the acidity of benzoic acids will increase, okay. Whether it is electron donating or electron withdrawing doesn't matter. According to ortho effect, the group present, if any group is present at the ortho position, the acidity will increase. So ortho group will have the highest one. So that is why I can have these two. I will eliminate these two. Now after that benzoic acid will be there. Next one will come paratolveric acid because it is an electron donating group. Okay. So that is why I will have option number D here. Okay. Clear? Option number D, all of you please remember. Will you remember about ortho effect? Many of you might forget. So please remember, if in benzoic acid, if any group is attached at ortho position, then the acidity will increase. Okay. Yes, Kanishk, with respect to ortho effect, we have to do it. Okay. Next, amines. So students, I will directly go to the questions of amines. So let's do some question practice from amines. Okay. I will give you the PDF. You can revise the reactions, but let's do certain question practice from amines. Okay. Shayad Fatah, see, mechanism I can explain, but that is not asked in the exam. Mechanism is not required, but I will explain at the end of the class if you require. Okay. But now let's focus on what is required for the exam. Okay. So let's do this question now. So if I have RMGX, okay, if I have RMGX and if I treat it with RNH2, okay, so now what you will see here, this RNH2 will donate one H plus. It is like this. Okay, this is the product, and here what is there? R minus and Mg plus X. So minus plus and minus plus will react. So R minus will take this H plus to give you RH plus RNH2. Let me make it R dash MgX. Okay, that will be the product. So first, if I take this one, what will happen? You will get a product X like this. So I have to just add one H here. So I will add H here. Okay, so I got a compound like this. So this is a 4-carbon compound. What can be the other isomer of this one? I can have one more isomer, like all the 4 carbons are in one chain. So that is option number 2 here. Okay, next question can we do from amines chapter? Next question, NO2, Br2, Fe, Br3. So what will be the product first? P. Have I given options here? No. Okay, let's do quickly. What will be P here? See, P will be NO2 and Br will be added at the meta position because NO2 is meta directing. With SnHCl, this one will get converted to NH2. Okay, and then with N2 plus and Cl minus, what will happen? This one will convert it to N2 plus and Cl minus and bromine. Okay, now if you give water, warm water, what will happen? This one will get converted to phenol. Okay, yes, so R will be this one. Okay, metabromophenol. Okay, next question, can we answer this one? Can we try this question? A hydrocarbon AC4H8 on reaction with HCl gives a compound C4H9Cl, which on reaction with 1 mole of NH3 gives a compound C4H10A. So let us see a hydrocarbon C4H8. So just write down first C4H8. You don't have to do anything. This is very simple question. See, a compound A is there, C4H8, and it reacts with compound HCl to give compound B, C4H9Cl. Okay, now this one is reacting with NH3, okay, NH3 to give C4H10N, that is your compound C. Now this one, if you treat it with NaNO2 and HCl, okay, so here you should remember one thing, that if I have RNH2, okay, and if I treat it with nitrous acid, okay, that will give me ROH. And if I have ArNH2, okay, and if you treat it with nitrous acid, then you will get N2 plus and Cl minus. Okay, so here this is definitely one aliphatic compound. If I treat it with nitrous acid, I will get one alcohol as the major product, right? So which option is having alcohol? You can see only one option is there with alcohol, so that is why option number B here. Next question, P, Q, R respectively are. So can we answer quickly? So P is there, N2 plus and Cl minus. So definitely I need what? Nitrous acid, NaNO2 plus dilute HCl. So I have this option, I can eliminate. Concentrated HCl is there, so I am removing that. All other three options are possible. Next, to add BF4 minus, I need HbF4. Okay, HbF4 is there, BF3 is not required, and here F2 is there, that is also not required. So that is why option number C here. Yes, all are answering correctly. Next question, can we identify here? Yes, CH3CN with Na and C2H5OH. Okay, so that one will first give me what? Can we identify what will be the product? This one will give me CH3CH2NH2. Okay, that is your A. Next, what will happen? If I treat it with nitrous acid, that is HNO2, that will give me CH3CH2OH. Okay, next with copper at 573 Kelvin, it will oxidize to give me CH3CHO, or that is your ethanol, option number D. Okay, option number D. Why here C, students? It will be D here. Yes, it will be D. Okay, all of you are saying D. Yes. Next we'll go, which of them will show Hofmann bromamide degradation? What is Hofmann bromamide degradation? If I have RCONH2, right, and you treat it with Br2NaOH, okay, that will replace this CO group with RNH2. Okay, so for this one I need this RCONH2 group. Okay, so what is RCONH2? Here there is both side NH2, so this one will not react. Okay, here RCO, next carbon is there, then NH2 is there, so this one is also incorrect. This is correct, RCONH2, that is option number C here. Yes, yes, C is the correct answer. Next, which is least basic? Now least, so whenever I want to find the basic order, see here, for basicity we need electron donating group. If electron donating groups are present, then basicity will be higher, right? So here you see this is an electron withdrawing group, so it will have least basic. Here this is an electron donating group, this is also electron withdrawing group, this is also electron withdrawing group, so all of them are not there. Electron donating group is there, so option number B here. Yes, all of you are correct. Kanish, Pavitra, please check your answer. It will be B. Hello Tejas. Hello Tejas. Next question. Next question, N2 plus Cl minus is there. I am removing that N2 plus and Cl minus. Means you are converting this N2 plus Cl minus with H. So what is the reagent required for that? Yes, for that we need, you can see here, I will just show you this reactions once. Just a minute. Yes, so you can see these are the reactions of benzene disonium chloride. Okay, so if I want to remove this N2 plus Cl minus and replace it with H, you have to use H3PO2 and water. Okay, you can use H3PO2 and water. So now if I see that question, where is that question? Yes, so H3PO2 and water, so that is option number A. Okay. Okay. Next, we will have aniline reacts with ethyl chloride producing compound A. A reacts with nitric acid. So first of all, what is there? Aniline is there. Okay. Aniline is there, reacts with acetyl chloride, that is CH3COCl, to give a compound A. So what will be this compound? If you know, this will be acetylated and we will get a compound like this, that is NHCOCH3. Okay. Now A reacts with nitric acid and sulfuric acid, produces compound B. So that is what you are doing, nitration. So in this case, what will happen? The nitro group will be attached to the para position. Okay. And this is your compound B. Now when you hydrolyze it, this group again is converted to aniline, okay, or NH2 group. NH2 group and NO2 group. So what will be this compound called as? This is your para-nitroaniline. That is option number C here. Okay. Yes, all of you are correct. Okay. Now let's move to the questions from some biomolecules. Okay, so students, before moving that, in biomolecules, what all things you must do? You must focus on the hormones, their functions. Okay, so please remember all the hormones, their functions, and their vitamins, and the deficiency diseases of vitamins. Okay, that is what you have to remember. Others are very easy here. So let's do some questions from let's do some questions from this one. Okay, can we answer the first question here? Stark OP Gaming, we will end by 11:30. I'm planning. Okay, let's do some questions, then we can end it. Okay. Okay, can we answer the first question, all of you? Yes, which of the following is a non-essential amino acid? So there are 10 amino acids. Non-essential amino acids is phenylalanine, option number D here. Okay. Next, deficiency of vitamin B1 causes which disease? Vitamin B1. This is very important. Every year questions have been asked from deficiency diseases. So please mark this correctly and tell me it is B. Yes, beriberi. Okay. Next, again, from deficiency disease, match the following. Vitamin A causes night blindness. So A has to be 3. So I can eliminate option number C and D. Next, vitamin D causes osteomalacia. That is 2 is 4. 2 is 4. That is option number B here. Okay. Okay. Sidhu, ma'am, look at previous questions. So Sidhu, which question you are telling? Can you please repeat? Okay, next question. Biologically active adrenaline and ephedrine used to increase the blood pressure contain which amino group? Yes, they contain secondary amino group, that is option number B. Yes, all of you are correct here. Next question. Glucose and mannose are. They are optical isomers, anomers, epimers, or chain isomers. Those who are saying anomers, it is wrong. Epimers is correct. Now, what is the difference between anomers and epimers? Listen very carefully, very important. If there is a difference in the configuration at any one carbon, means any one carbon there is a difference in the position, all other carbons have same position, in one carbon there is difference, then we call it as epimers. Okay. Now if that one carbon on which the difference is there, if it is carbon number 1, then we call it as anomers. So in glucose and mannose, what happens? The configuration is different at carbon number 2. The configuration is different at carbon number 2. So that is why they are not anomers, because it is not on carbon number 1, but they are epimers. Okay. So it is epimers. You can see the structure of this one. You can see at C2 position, glucose and mannose are having different configuration. Okay. Okay, next we will go to coordination compounds. Some questions from coordination compounds I want to discuss. Some, yes, okay. Okay, Pravan. Priyadarshini, yes, all the organic chapters and inorganic chapters we have done, and physical chemistry we have already done in the previous session. Okay, so what is the IUPAC name of the given compound? Students, please answer the question. Yes, what is the option answer? So I need, right, this pentaamine should be there, right? So first option I can eliminate, other three options are correct. Pentaamine, then I need to say CO3. CO3 is named as carbonato. Okay, it is named as carbonato. So this is carbonato is there, here also carbonato is there, here carbonate is not there, so eliminate this one. Next, cobalt is there, here cobaltate is there. So you know this is a cation, right? In cation the name doesn't end with ate, so this is also wrong. We have option number A here. Okay, next question, formula of penta aqua nitrato chromium 3 nitrate. Yes, so many students are answering and they are giving correct answer. That is really making me happy, and I'm very sure that all of you will do very good in tomorrow's exam, and my wishes, good wishes are all with you people. Okay, so don't get nervous, everything will be fine. Okay, so can we have this one? First we have penta aqua, means 5 H2O group should be there. Here there is 6, here there is 6, we will remove. Then nitrato is there. Okay, this is nitrito and nitrato is NO3, so that is why option number C here. Okay, not D, C. Those who are saying C, D, it is wrong. Nitrato means NO3. If it is NO2, it is nitrito N or nitrito O will be written. Okay, because it is an ambidentate ligand. Okay, next question. Which of the following will be able to show geometrical isomerism? Geometrical isomerism. Tetrahedral molecules do not show geometrical isomerism, and in geometrical isomerism of coordination number 4, okay, if coordination number 4 is there, then we can have geometrical isomerism in two cases, if it is in this form or it is in this form. Okay, and for coordination number 6, what are the possible configuration? You can get MA4B2, here I can get geometrical isomerism. MAA3, here I can get geometrical isomerism. MAA2 and L2, here I can get geometrical isomerism, and next one is MA3B3. Okay, these are the 4 possibilities where we can get geometrical isomerism for coordination number 6, and for coordination number 4 we have these 2 possibilities, and tetrahedral will never show geometrical isomerism. So MA3B, does it falls in this category? No. So MABCD, that is option number D. Now here you remember, in ABCD we will get 3 geometrical isomerism, out of which 2 will be cis and 1 will be trans. Clear? Okay, next question. Which of the following system in octahedral complex has maximum unpaired electrons? Now see, whenever it is written high spin, okay, high spin means there will be no pairing of electrons. Okay, and low spin means you have to do pairing of electrons. Okay, so now let us see D9 high spin. So D9 configuration, if I just draw like this, okay, D9, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So what is the configuration or number of unpaired electrons? Here is 1. D6 low spin. If I want to do D6 low spin means what I will do? Pairing will take place, right? So if I do pairing of electrons, 6 electrons, 1, 2, 3, pairing will take place 4, 5, 6. So here unpaired electrons is 0. D4 low spin. Again we have to do pairing of electrons. So if I have D4 low spin, what I will do? D4 low spin, 1, 2, 3 and 4. Okay, so number of unpaired electrons here is 2. D7 high spin. High spin means no pairing of electrons. So I can have like this, D7, yes, D7, 1, 2, 3, 4, 5, 6 and 7. So here I have 3 unpaired electrons. So where I am getting maximum number of unpaired electrons? Option number D here. Okay, yes, all of you are correct. Yes. Okay, next we will have crystal field splitting energy of CoCl6 is 18,000 and the crystal field splitting of CoCl4. So what is the relation here? Delta T is equal to 4 by 9 of delta O, right? So 4 by 9, you can see here CoCl6 is delta O, that is coordination number is 6, and you want to find for delta T, that is 18,000. So I can just multiply, it is 8,000. Okay, so that is your option number A. So those are saying A, that is the correct answer. Next question, the correct order of wavelength of light absorbed in the following complexes. Very, very important question. Yes, this is very important question. All of you, please do this question properly. Yes, very important question, this one. Now see, just Fareen has a question. Ma'am, I have completed half revision an hour ago. Then how and when I can attend this class? Fareen, we will be finishing this class. You can watch the recorded session. Okay, make it 2x speed and just solve questions and revise all the reactions that we have discussed in this class. Clear? Okay, now let us see this one. See, whenever you have strong field ligands, okay, the splitting will be very high. Whenever I have strong field ligands, the d orbitals will split very high. Now to excite the electrons, okay, suppose if a strong field ligand is there, the splitting will be very high. Now electrons will be present here, electrons will be present here. To excite this electron, I require high energy, right? If energy will be high, then wavelength will be less. Okay, now the question, if you see what is the splitting order, if I see what is the splitting order, here all are NH3, this is the strongest ligand. After that we have Cn, and here we have first is Cn is the strongest field ligand, so 3 will be highest splitting. Then here you can see all are NH3, here 5 NH3 and 1 chlorine. So this will come next and this will come next. So this is the splitting order. Okay, the order of splitting. Now here there will be maximum splitting, maximum energy or least wavelength. So wavelength order will be 1, 2 and 3. That is option number A. Okay, those who are saying A, that is correct here. Okay, those who are saying A, that is correct. Okay, no Nazia, this is the last part. We have revised all the chapters, right? So no more parts. Okay, so for D and F block, we will be discussing certain oxidizing properties I want to discuss, okay, from where questions can be asked majorly. Yes, so DNF block, I want to discuss the main part of the chapter where there is oxidation. Okay, oxidation is there. Oxidation is an oxidizing agent. KMnO4 is an oxidizing agent. So here this reaction is very important. I minus is getting oxidized to I2 in the acidic medium. Okay, next what all oxidization reactions we have? You can see S2 minus gets oxidized to S, SN2 plus to SN4 plus, Fe2 plus to Fe3 plus. Okay, now this is important in the acidic medium. Okay, next we have you can see the methods of preparation of permanganate. This type, from here also question is asked. This reaction will be given. It will be given in the form of fill in the blanks. You have to do this reaction. Okay, that is there. And next we have here the structure of MnO4 and MnO4 2 minus. So remember what is there? MnO4 minus is green in color. Okay, this is paramagnetic because it has one unpaired electron. MnO4 2 minus, this is MnO4 2 minus. Okay, now MnO4 minus, that is permanganate. It is diamagnetic and it has no unpaired electron and it is purple in color. Okay. Okay, so students, these are some important concepts that you should be revising. Next comes this one, chemical properties of MnO4 minus. Okay, so MnO4, okay, gets converted to Mn2 plus in acidic medium, MnO2 in neutral medium and MnO4 2 minus in the basic medium. That is first you should know. Then what is its application? You can see about I minus. Okay, I minus gets converted to I2 by MnO4 in acidic medium. NO2 minus gets converted to NO3 minus, SO3 2 minus gets converted to SO4 2 minus. Okay, and similarly we have some more reaction here where you can see S2 minus gets converted to S, Fe2 plus to Fe3 plus, C2O4 to CO2. Okay, this you should remember what is changing to which one. And the most important thing is the next one, that in basic medium, or you can say neutral medium, okay, neutral medium, I minus gets converted to IO3 minus. In acidic medium, I minus will gets converted to I2. Okay, so students, these are all the things that I want to discuss. Okay, okay, clear? So students, now if you have any specific doubts, I'll be providing this PDF. All these notes are available. Just revise that once today in the afternoon. You can just go through this entire notes, and my previous previous physical chemistry session and this organic chemistry and inorganic chemistry session, if you revise properly and do the questions that has been given in this particular session, everything will be done and you can easily score 35 plus to 40 plus. Okay, I can guarantee you that. So Rahul ji, physical chemistry I have already discussed. One more live session was conducted on Sunday evening 5 p.m. You can just go to the channel and just check the live session. There you can see entire physical chemistry of PU1 and PU2 I have completed there. So please do watch that, and I will be giving this PDF. Okay. Okay, Aisha has a doubt. Please explain empirical formula and molecular formula. Okay, Aisha, see here, I am taking your this doubt. So students, if you have any specific doubt, you can put down here. Now see, for example, I have C6H12O6. Okay, this is the formula of the glucose, all of you know. Now if I cancel this, I can cancel it like this. Okay, this is molecular formula and this is empirical formula. Empirical formula tells us the ratio of the atoms present in a compound, whereas molecular formula tells us the exact formula of the compound. Now how to find empirical formula? Suppose you will be given with the elements, okay, their percentage will be given. For example, carbon is present 24%, okay, hydrogen is present suppose 16%, okay, something like that. And if I just take 6 plus 4, 10 to, okay, I'm just taking any random number, okay, just a minute. Okay, so suppose carbon is present A%, hydrogen is B, oxygen is C. The second step, what you have to calculate, number of moles. Okay, number of moles, how we can calculate? Percentage by the molar mass. So what is the number of moles of carbon? A by 12. For hydrogen it is B by 1, and for oxygen it is C by 16. Right, this will be the number of moles. Then second step, what you have to do? Simple ratio you have to find out. Simple ratio, what you have to do? The one which out of this value, suppose this is 1, this is 1, 2, and this is 3. The one which is the smallest value will be divided throughout the other values. So I will get here 1 by 1, here I will get 2 by 1, here I will get 3 by 1. Okay, so now you will get a simple number out of this. So I got 1, 2 and 3. So that will be the empirical formula, CH2O3. Okay, so this is just a random example how to find the empirical formula. Okay, okay. Okay, so now there is some doubt. Ma'am, please explain coordination, hybridization and crystal field. I only know IUPAC. Okay, so let us talk about coordination, number, IUPAC and all. Okay, so just a minute. Okay. So students, for valence bond theory, okay, these are the things that you should remember. Okay, in valence bond theory there are certain compounds which will be asked in the example. So this table is very, very important. If there is a strong field ligand, okay, then it will be always, most of the time it will be D2sp3 hybridization. For weak field ligand it is sp3d2 hybridization. For coordination number 4 and weak field ligand sp3 hybridization, and NiCN4 strong field ligand it will be a dsp2 hybridization. So you have to remember this table. You can solve questions easily. You have to remember the hybridization, the geometry and the magnetic properties. Okay. Yes. Coordination number calculating. Sidhu, Coordination number is very easy, dear. You can just see. So for example, you can see how many bonds are formed here. How cobalt is forming 6 bonds. So coordination number is 6 here. Cobalt is forming 6 bonds. So here also 6. Here it is 4 and here it is 4. Now for example, there are certain compounds like this. Just a minute. Okay, just a minute. Okay, so if you see this particular compound, okay, if I see this particular compound, that is COCl2En2. Okay, now how to check its coordination number? See, En2 is a bidentate ligand, means it forms one En forms 2 bonds. So one En, you can see 2 bonds are forming, another En is forming 2 bonds. So total here 4, and this chlorine is forming 2 bonds. So total coordination number here will be 6. Okay, so if you know the ligands, then you can calculate the number of. Yes. Clear? Raghu, coordination, like how you explain organic. So dear, coordination, see, first of all, what all things we have been in coordination. First is your Werner's theory. In Werner's theory, you should know what is a primary valency, what is a secondary valency. Okay, primary valency is the oxidation state of the metal. Secondary valency is the coordination number of the metal. That is the first thing in the chapter. Next, what we have to discuss, here's a question. Can we answer this question? Addition of excess of AgNO3 to an aqueous solution of 1 mole of PdCl2.4 NH3 gives 2 moles of AgCl. So 2 moles of AgCl is formed. That means 2 chlorine should be outside. So what is the formula of the compound? PdNH3 4 and Cl2 should be outside. Now if I just write down this one, it will be in this form: PdNH3 whole 4 2 plus and Cl minus. Okay, so this is the cation charge is 2, the anion charge is 1, so it is a 2:1 or 1:2 type electrolyte. So option number C here. Okay, Kushal Ravi, ma'am, 1,2-dichloroethane is an example. It is a bidentate ligand here. Okay, okay. Yes. Okay, so next coming to this one, isomerism. Okay, all of you please understand isomerism. Let's discuss here. All of you are asking here. So isomerism, first of all, is of 2 types. One is your stereoisomerism, next is structural isomerism. Under structural isomerism, you have linkage, coordination, solvation isomerism and ionization isomerism. In case of geometrical isomerism, we have coordination number 4, square planar and tetrahedral. In coordination number 6, Ma4B2, Ma2LL2 and Ma3B3. I have already shown you that, right? So these are the isomerisms that is existed. Okay, so you can just see these diagrams. So in MX4L2 there is cis and trans, in MX2L2 there is cis and trans, in MX2L2 there is also, so this is actually Ma3B3. Okay, in Ma3B3 we will have facial and meridional isomers. Okay, number of isomers for inorganic chemistry, number of isomers, who is asking this one? Stuti Nayak. So dear, for number of isomers in these type of compounds, you have to draw and check. In organic chemistry there is formulas, but that is not there. In means that type of questions are not asked in the exam. But in for organic chemistry, the number of isomers is 2 to the power of n, where n is what? Number of stereo centers. Okay, but that is applicable for organic chemistry, not in inorganic chemistry. Okay, mesoisomers. Mesoisomers means, dear, where you have a plane of symmetry. Like for example, if I have a compound like this, CHO, OHH, OHH and then CHO. Okay, so you can see there is a, means this upper half and the lower half are exactly opposite to each other, right? So these type of compounds are called as mesoisomers. Okay. Okay, so students, I will be giving you this PDF. Please quickly join our WhatsApp channel. Okay, in the WhatsApp channel, after this class immediately I will be uploading the PDF. You can download it from there, and please revise this whole concept. Just go through it quickly and do the questions that I have discussed. And I have also taken live sessions where we have discussed very important questions. If you have time, you can go and watch that, or else today just revise this particular PDF. I will be uploading it, and my previous session PDF also I will upload. Okay, 2 PDFs I will give you, that, and 1 top 100 questions PDF I will give you. You revise these 3 PDFs, your exam preparation will be done, it will be improved. Okay. Okay, so tricks chemistry video. Okay, I will try to make a video on tricks by the evening so that you can watch it and prepare for tomorrow. Clear? So that's all, students. Okay, Lavanya, I have already explained boiling point. Okay, I have discussed the boiling point that you have asked. Okay, yes, physics class, students, the physics class is live at 12 p.m. So that is why I have to leave now, so that you can take a break of 30-40 minutes and join sir's class as soon as possible. Okay, that's all, students. Let's end here, and all of your doubts, if you have any concept wise doubt I have not taken in here, please put down in the comment section, and immediately join our WhatsApp channel. I think in this video, if you go, just check the, just a minute, let me just see, 1 second. Okay, so you can see in the description section of the video, you can see the link for WhatsApp channel. Okay, just go to the video, click on the description, you can find the link of the WhatsApp channel. In that link, click and join the WhatsApp channel. Now I will end the class and I will upload the PDF of this session, the previous session, and top 100 question session. Okay, that will work, all of you. And students, please don't be nervous. Okay, you all are doing really well, and you all will do very good in the exam. Question papers will be easy. Okay, yes, today no need to revise 11th. Okay, please, today don't revise 11th. You don't have that much time. Just revise, focus on PU2 as much as possible. Okay, my children. Okay, making money, students, I will upload the PDF. Please do not worry, I will upload the PDF. I haven't done yet. Kushal Ravi, which order reactivity you are asking? Like, for example, is what order? There are different orders, right? Reactivity, if you want, it will be in terms of SN1 generally. So more the stable carbocation, more will be the reactivity. Okay, that is where we can get the questions. Okay, Kushal Ravi, I have answered your question. Hi Vishwa Rathod. Okay. Yes, Mr. Strange, what all things are required for the exam, what all things you need to carry, I'll make a detailed video on that. Please don't worry, just wait till the evening. All your questions will be answered in that video. Okay, thank you everyone, all the very best, students. I will be waiting for you tomorrow. After the exam, we will have paper analysis. Okay, and do not worry, today please relax and revise only PU2 chapters. Don't go for PU1, and calm down yourself. Okay, don't panic at all. Everything will be good. You all will do good in the exam. Question paper will be easy, so don't worry. Okay, all the very best, and see you soon tomorrow evening for paper analysis. Okay, making money, organic chemistry, I have discussed later today's class. Yes, Pavitra Nair, these 2 videos are enough, and the top 100 questions video. Okay, that too will be there. Lavanya Muniraj, you deserve an award. Definitely, Lavanya, if you score well in the exam, that will be my award, right? So all the very best. All the very best to everyone here who has been watching this video, and I really wish tomorrow all your exams will go very good. So please don't worry and don't panic, my children. Please don't get nervous. If you get nervous, tomorrow exam you will spoil it. Okay, so chill, calm down, relax yourself, and don't be nervous at all. Everything will be good. Okay, that's all, and see you soon tomorrow. Bye bye, and go and study. Take some break now and get ready for physics live class at 12 noon. Okay. Okay.